It's better? Yeah, cool. We'll get started once everybody can hear me. Okay, can you guys hear me okay? All right, welcome to the Cisco Youth Theater. I am Kareem Iskander. I'm a principal engineer with Learn with Cisco. I lead the technical advocacy team. We do all of this, and I've been with Cisco for 17 and a half years now, straight out of college. Uh, Dabbled in a lot of roles. Prior to this, I was in DevNet and I did a lot of automation. And I know we talked to you a lot about automation, and I wanted to put this session together to do a couple of things to show you how you can easily use Cisco APIs and automation today from an event-driven perspective. So you let the product do the heavy lifting of your automation. But I also wanted to give you a way to show you how Splunk plays in our automation realm. And on top of it all, I wanted to put that use case together and see how it is relevant in our agentic era now, or AI that we're doing. So there's going to be a lot of content that's going to be thrown at you, but I'm hoping that you'd walk away with the use case, maybe somewhat that you're trying to implement on your end, to give you an inspiration and idea of how to get started. So I'll just give you a quick introduction on what event-driven architectural is. You might be familiar with it if you've done some automation. And then we're going to look at the different players in this use case that we're building, between NetBox, events, how we can leverage that, how we integrate Splunk Heck. If you were in Quinn's session prior, he went through all the different ways to bring in data into Splunk. With Splunk Heck here, it plays nicely when you're building and architecturing your automation to be more on the event-driven side. And then I'll use Meraki as my network controller, my cloud controller. This use case could be applied if you have Catalyst Center, or if you have your own kind of a RESTconf, NetConf script direct to the devices, right? So it doesn't really matter. Meraki is there from a network operation perspective. And then we're going to overlay all of that at the end with AI, and I'm going to talk to you briefly about MCP and how does it play. And then I'll give you a demo of everything that happened, okay? Let's make it interactive. If you guys have a question, please feel free to raise your hand. I'm happy to answer it as I go. You're here to learn, and I'm happy to do so. So when we talk about EDA or event-driven architecture, we're talking about a software design pattern where you're essentially decoupling the components that communicates through events. Think of it when you're doing any API calls, you're going into the API service and you're saying, hey, give me data and give me a JSON payload, update data. So you're doing and handling that automation and that request for data from your network devices. With event-driven automation is based on whenever happens rules that you set in your network, a webhook, an event, will be pushed out to an endpoint that you define, and you would receive that payload. So you're not sitting there and saying, hey, give me data, give me data. You're just listening until the network tells you something is happening, and here is the payload. Do something with it. And so in event-driven automation, there are a couple of pieces that you should know and understand. You have the event producers, and these are what they generate, the pieces that generate events for us. Think of a producer as Meraki. Meraki is a network controller. It has the capabilities to set up webhooks, and with webhooks, you push out events, and it's considered a producer. You also have the brokers, the mechanism that allows you to basically transport those events over something. And there are a couple of brokers that you might be familiar with. The very obvious one that a lot of the products have from a producer or a broker perspective is webhooks, and it's over HTTP, very similar to APIs, where the JSON payload is sent out. There's also other things, especially if you're in cloud or and implementing very similar architectural in a cloud instance. You have a Kafka bus or a MQTT, where from an MQTT perspective, you create a topic and you subscribe to that topic. You push events out to that topic, and you will receive those events on your end. So that's the bus that transfers our events, our webhooks, or our payload, I should say. And then you have the consumers, the pieces, the entities that are going to receive a payload, and a payload is typically in a JSON format, is going to do something with it, right? That consumer could be your custom script that you built, a Python script sitting in a Lambda function somewhere in AWS, just listening, a Flask application that you have in your infrastructure that you point to, and you get some data from as these events get fired. Or it could be a product itself. Splunk is a great example. Splunk has the capabilities, and we're going to dig into what heck is with Splunk, to basically open up an endpoint so you can send payload into Splunk and you have a single source of log with Splunk. And we'll see how that is implemented. Does this make sense? Does this kind of put it in perspective for you what EDA is in a sense? Okay. So let's look at network automation as we know it. And this is something that we've been talking to you about for years on how to automate your network. Maybe you have some type of network automation APIs where you have a script. That script handles, you're building a use case with auto deployment or zero touch deployment with Catalyst Center. Maybe you have a multi-site with Meraki, and you want to notify your operations team whenever anything happens to your network via WebEx, and maybe you're monitoring the device temperature with Grafana dashboard, or maybe you're building an AI application and you have some type of vector database running. If you're automating all of that, these are different API endpoints and different pieces that you, as a network automation engineer, you'd have to handle yourself. You'll have to go and build whatever that script is, Ansible, Python, it doesn't matter. You'll have to handle the API calls to Catalyst Center. You have to handle the API calls to Meraki. You'll have to monitor all of that. Whenever you need to make any updates, you have to execute that script. And it's, especially if you're doing some type of audit log, it's a lot. It becomes very heavy. You have a little bit more flexibility, but it's really heavy. And especially when it comes to comparing and making changes to the network, you still have to handle all of these endpoints yourself. Now, if we flip that on its head and we go the other way, where we're leveraging event-driven automation, you have the different pieces in place. You configure the different endpoints where you want the events to be sent out, and then your job is done because everything is handled under the hood for you, which means if we look at the same example where we're maintaining a single source of truth with NetBox, you start your event, you have NetBox, you've documented your network configuration in NetBox. From there, if you go in and make any changes into NetBox, you define that event in NetBox saying, whenever I update a config, I want an event to be sent out to this endpoint. And so you go in and say, I'm ready. I made some changes. NetBox is going to realize that a catalog has been updated. It goes out and it ships out to the event, to the endpoint you've defined. You receive that via the event broker itself and say, okay, now I have a change in NetBox. I need to know what's going to happen with this. So you maybe have some middleware somewhere, a traffic controller that says event happens in NetBox. I know somebody made a change to my Meraki site. I can take that and I can push out that event to Meraki, and Meraki can in turn stay one-to-one with the source of truth. So all of that with just basically maintaining a traffic control in the middle, where you don't have to make any API calls or any pull requests from the services, so you can maintain your network. On top of it, once a configuration change in your Meraki dashboard, Meraki itself acts as a producer and where you can hook in Splunk. So you have a single source of log with Splunk where you say, whenever I see Meraki, whenever a configuration change in your dashboard, go out, fire off another event to Splunk and send that data out to Splunk so I can trace it and maintain it somewhere. And that endpoint that I'm going to be sending that data out to, it is essentially a Splunk hack. We're leveraging Splunk hack to ingest that data into Splunk. So that's the use case we're going to build around, and we're going to see how we can configure these pieces. Does this make sense? Okay. So let's talk about the use case. Carl here is our network automation engineer. He's confused and he's been tasked with maintaining a single source of truth for his network configuration. He's been asked to automate config changes and prevent config drift, so he doesn't have to go in and out of the different pieces to update that. Once it updates in the source of truth, it should propagate throughout the entire network automatically. And then for security and audit purposes, he was also asked to essentially maintain a single source of log with Splunk. So if we look at just this use case, I'm sure you've encountered this use case in your day-to-day job or something very similar to that. These are the pieces that we're gonna look at. Our source of truth is NetBox. Our controller in this case is Meraki, Cisco Meraki. I'm using a very simple Flask application and Lambda function. Um, Depending on where I'm demoing this, I deploy it. But for today, it's a Lambda function, a middleware somewhere, where basically it's my traffic controller that says an event came, this came from Meraki, go do this. And then finally, I have Splunk as my observability with all of this. If we look at how this designed, there are a couple of pieces you should know. First of all, we always want to start from our source of truth, which means if you're going to make a configuration change to your network, go document it in that box and let everything else flow. So in that box itself, we have to document our network, obviously, right? And then we have to configure two pieces in that box. Configuration, a change management event trigger, which says when a document is updated in that box, go fire off a webhook to this endpoint. And in our case, this endpoint is the Flask application because I need to be able to see what devices and what configuration has been updated. And so it's a simple Python script that traverses that JSON and receives the payload and decides what to do next, which basically extrapolates the serial number for the device itself. It extrapolates the new values that were updated that coming out of that event payload that was sent out, and then ships that out via APIs, via Meraki APIs, and says, here, these are the configurations that you should update. So that's the only time we're leveraging APIs in our EDA, in our event-driven architecture. From this point on, Meraki acts as another piece of this where now it has that configuration change. Some things needs to happen. I need to be able to first audit those changes. So I need to push some events out to Splunk. I also need to apply those changes. So within Meraki itself, we go in and you configure, or we configure that as a consumer and a producer, and we say, I want to be able to ship out events based on the configuration changes, and I'm going to go define alerts, which is actually really important. You get to pick what threshold on which alerts are shipped out to Splunk. And for those who have Splunk in-house, you know that Splunk charges you by the size of that database. So with event-driven automation, you, especially if we're using tech under the hood from a Splunk connection perspective, you don't have to push out all your logs to your Splunk instance. You get to pick and choose which events you want to see in that single source of log. And then finally, Splunk receives that event. So whenever Meraki dashboard will apply a change, it will fire off an alert that you've picked, and it will ship that out automatically to Splunk. Splunk will say, hey, here is an endpoint that you've you can use to for me to ingest your logs. Okay. And that's basically putting all of that together. The configuration will probably take you about 15 minutes once you understand the different pieces. That middleware is maybe 15 lines of code. You can leverage, and if you want to get fancier, you can leverage event-driven automation with Ansible that would allow you to actually just run a playbook for automatically whenever an event, a webhook gets received into that Ansible playbook, which is actually really cool. Any questions on this? Okay, so let's look at the different players. NetBox events. There are a couple of pieces in NetBox that you could do. A couple of things. If you have a managed instance of NetBox in AWS, you can actually go in and set up webhooks to be fired off to your middleware somewhere automatically. But most likely what you have is you have your own instance of NetBox deployed somewhere internally, and the way that NetBox handles this is you basically go in and trigger an HTTP post request for a specific NetBox change. It could be a record is deleted, a new record is inserted, a record is updated based on the different types, the CRUD essentially in NetBox. You define and you decide which endpoint that event gets fired off to, and you set that up via the UI, and job's done. You basically provide a URL. That URL is your listening, your webhook listener, and whenever anything that a rule happens, which is update, delete, insert in the NetBox, a payload gets fired, and the payload contains information about the network, new values that were added, old values, what it used to be, and what actually the device serial and all of that. So whatever you've documented in NetBox. This is what kind of the NetBox webhooks and event rules look like. So I have this is NetBox, what it looks like. You go set up event rules and you go set up webhooks. The event rules, this is where you're telling the action that needs to be taken whenever something happens. And this is the endpoint of where that webhook is going to be posted. And a JSON payload looks simple, something very similar to this. It's simple JSON giving you information about your network. Now, the next piece that we need to know, and I want you to focus, and this builds on Quinn's session from previous, is before we get into the Meraki piece, the Splunk configuration, because what Splunk gives you is it gives you a way, an endpoint for you to basically pump data into it. And this is where Splunk HEC comes to play. And so Splunk HEC, or HTTP Event Collector, is a service that allows clients to send event data to Splunk via HTTPS. It also supports HTTP, but if you're using Cisco products, you have to send it over a secure HTTP. So if you're trying to do this without a cert in Splunk, Meraki is going to ignore the traffic that's coming into it. Just be mindful of that. It's useful for device where forwarders can be installed. So HEC is really good because it uses HTTP. If you have port 8080 open on Splunk, it allows you to actually send that data out, and it's token-based authentication. So think of it as basically you're opening up a receiver within Splunk over HTTPS. Once you've configured that receiver in the HEC receiver into Splunk, you link it as part of the process, and I'll show you this as part of our demo. You link that live to directly to a Splunk index, and once you have it in a Splunk index, that data is available in your search head, and you can start searching, querying your logs, figure out what happens and what's going on. Meraki does a really good job with connecting because it also allows, Meraki has the capabilities to be able to send out events. What Meraki does is sends out old values and new values of what changed in your network config. And if you have all of that in Splunk, it makes it very easy to traverse any changes, accidental changes that happen in your network. Any questions? So configuration is this easy. You go into Splunk, you say, I want to create a new token. Once you create a new token, you go through a simple wizard, you give it a name, you configure where you want that the data, the payload to come into and which index it needs to be saved at. Splunk generates a heck URL. That's your receiver for you. And I want you to be that URL always looks the same. It's your Splunk server. It's secured, so it's running on port 8088. One thing that you got to be mindful of is if you have a Splunk instance running it's not a managed service, just make sure that these ports are open on your VM or your container that you're running this into, and then /service/collector/event. It's always this URL when you're creating a heck. If you're running it without unsecure over HTTP, the port would be 8080. So those are two things. It's part of the Splunk documentation if you want to read more around the different ports that are required. Getting started with this, I was blocked for probably a day because my payload was not, my webhook was never getting ingested into Splunk, and that's because my port was blocked on my VM. So just be mindful of that. So the good, bad, and the ugly of heck. Security risks without proper configuration. So if you don't have SSL encryption is not used, your data is sent, but that's just common sense, right? That's normal with anything. It's reliance on custom clients, which means developers must implement logic to format that data in JSON and handle the HTTP headers. And then there is no, unless there's a checkbox as part of the configuration that you do for Splunk heck. Unless you select indexer acknowledgement, Splunk will not tell you if it received the payload or not. So if you're not getting the data, you'll actually have to go to the internal Splunk logs and figure out what's going on. You don't get hey, I received it, kind of like an API 200 OK. You don't receive that. And then, like I said, the port and firewall dependencies, this is something that could get you when building with heck. All right, this is Splunk. We have NetBox in place. Splunk is ready to ingest data. Now, the big piece of it is our middleware, our network controller itself. And in this case, our Meraki events. There are a couple of pieces that you should know. So Meraki allows you to send out logs to Splunk directly from syslog protocol. You basically use universal forwarders option. I think Quinn covered that in his previous session, where you essentially say, hey, here's a Splunk URL. Here's an IP address on this port. You go into the Meraki dashboard. You say, anything happens, if as soon as I log in, or somebody changes a name, or somebody deploys a new Wi-Fi, an event will be the syslog. This will be shipped out to Splunk. The negative part of this is there's no control on what gets ingested into Splunk instance, so your database could be pretty massive and it could get costly. But it's easy to get started. There's not much to it. It's just an IP address. You put it into the Meraki dashboard and you set it and forget it. Okay. What we're talking about here is event-driven automation. So we got to leverage webhooks, and Meraki does a really good job with implementing and having the capabilities to send out webhooks. And so within Meraki itself, you go in and you say, a couple of pieces. I have the Splunk heck, that URL that was given to me by Splunk. I'm going to go create a new webhook. Within that webhook has to be attached to a specific template. Splunk uses liquid templating. If you're familiar with Jinja 3 templating, it's just a templating language by Shopify. And I'll show you what that template looks like in our demo. And from there, you say, I have a webhook. It's attached to this template. So any data payload is going to be shipped out is going to look like this. Now I can go into my alerts and specify what do I care about to be shipped out to this on top of this webhook to Splunk. So I can pick maybe when a port is down for more than 5 minutes, or when a configuration changes on my switches, or maybe I want to see if a new admin has been added to my organization. So you are in charge of which events get sent out into Splunk itself via this method of Meraki. And this is essentially what we talked about. You go build a webhook template, you specify the Splunk heck that we got from our creation from the previous step, and then you simply go in and pick those alerts. Okay, so I have about 5 minutes, and I'd like to go through the demo. This is essentially putting it all together in a perfect world. This is what you would do. You would have this, these are kind of connected together, events are firing off, triggers here and there, and you have everything that you need. Now, when we talk about managing all of this, if you want to see a configuration change, maybe somebody went in and made a change to directly to Meraki dashboard as opposed to going to Netbox, and now you have a configuration drift. You have to go in and play the kind of detective and figure out what changed, what is it supposed to be, who made those changes, query Splunk, and have to do all of that together. But we're in AI era now, so there must be a better way to leverage agents to be able to allow us to pump all that data into safely into the AI and have the model make the decisions for us. And so this is where MCP comes in play. I'm not gonna dive deep into MCP, but I want you to think of it as this. MCP, think of it as a USB port into a big large language model. It allows you to basically connect different tools into the model, and you hook that in, and you can now query your context, your world. With leveraging MCP, it's a client server relationship, so you have some type of client, cloud desktop, but servers are essentially what allows the model to have access to these tools. Tools are basically API endpoints that come from the services, which means if we have a MCP server for Splunk, and we have an MCP server for Meraki, and an MCP server for Netbox, we can build out our entire use case and manage it completely via AI. So we're not doing the cross examinations ourselves. So I'd like to actually get to the demo piece for you to give you an idea. Before I go in and show you the different pieces, is there any question on any of this? Okay, so let's look at it. Let's look at the two main pieces. The NetBox configuration, you saw that is super simple. There's nothing to it. First of all, configuring Splunk, we said we need heck to configure. So within Splunk itself, and I'm running Splunk Enterprise here, I can go into settings, data inputs. Can you guys see this well in the back? Yeah. HTTP event collectors. I simply go here and I say, like I said, I'm going to go create a new token. I go through the wizard, give it a name, so forth, and the end result would be the URL that we have and the token to authenticate. Now that I have these two pieces, I can go into Meraki and say, okay, if you guys remember, there are two pieces to Meraki I need to configure. I need to configure that liquid template, and I need to configure that webhook to say, here's what you're going to ship out any changes. So if I go out to Meraki itself in organization, APIs, and webhooks, under webhooks here, I have my Splunk URL 8088 service collector / events. In this case, I'm just choosing raw data to be pushed out. It's your preference. The shared secret is that token that Splunk gave us when we create the heck. And now you have an endpoint that all the data is going to get pushed into. The next piece was what? To go select the different alerts that we want that event EDA to be shipped out whenever the alerts, the action takes place, which means I can go into network wide alerts. And here, I've defined my webhook right here, webhook Splunk. Can you guys see this better? Yeah. So I've defined my webhook Splunk, and these are the rules I get to pick. Network wide, configuration settings change. That's an event is going to get fired off. Or maybe wireless, a gateway goes offline after 60 minutes. An event is going to get fired. So you can pick and choose from all of the different pieces of your network. Switch device, any port goes down for more than 5 minutes. That Meraki is going to fire off an event to that webhook that we've defined, and now it all exists together. We have our source of truth configured to basically implement any changes whenever we make a change in that box, and it's all basically playing together. Now, I want to show you, this is how easy it is to configure all these pieces. Now with AI in play, I can actually go into, and I made some changes prior to this session. I can go to my AI here and say, so if you look at here, I have 3 different MCP servers. I have my Netbox, Meraki, and Splunk. And I can actually go and query, show me what changed recently in my Meraki dashboard via Splunk logs. So it's going to actually go, and because I gave it very simple instructions, it's going to look at, actually I need to actually, I'm going to stop this because everything that I've changed is in my Cisco U, in my Cisco U org. So it's going to know that it needs to go out to Meraki to pull out that Cisco U information, hopefully. Here you go. So it went over to using the Meraki MCP server, and it looked up for that org. So it needs to pull out an org ID from my Meraki, and it's gonna cross-examine that log, that org ID with the data that it has into Splunk, and it's gonna give me a report of all the changes that were recently made. So it found it, searching Splunk now, and you can see what's great about this is I didn't tell it to go out to the Meraki index to search Splunk. It's just inference that from what it knows about my the different MCP servers that it has it connected into. And also what's great is, I don't know how many of you have used the Meraki query, the Splunk query. Its language itself, it's heavy. So it's going to keep retrying until it actually gets data for us and see what's going on. So it got an error here with Splunk, within Splunk. It's going to keep, now it's going in to learn more. So it's listing the different indices that it has into my Splunk index, into my Splunk instance. And I wish this was a little bit faster to get to it. Yeah. But it's eventually going to hear, perfect. There's a Meraki index, and then now it's going to try again and look at the different indices that are the Meraki index, and look at the data in it. And it came back with a payload, right? And it printed out the changes that recently happened. So it looks like there was a change. I think this is the change I just made prior to this session, but the time zone is it's US. Yep, these are changes I just made before the session. It tells you that the change rename campus switch to this, IP addresses for this switch has gone from that to this. So I can actually go, would you like me to? No, I can actually go further and say, check my source of truth. and tell me if there is a drift. So we have the log, we have events firing off from NetBox. In this case, I made changes directly into my Meraki dashboard, so NetBox does not match my configuration in Meraki. And it went and used the NetBox MCP server to go and look at the configuration that I've documented in my source of truth. And it received information about my Meraki dashboard or my Meraki switches and APs from that box, and it's going to cross-examine what's current versus what has been documented. And it spit out a really nice report for us that says, here is what happened. So I could further investigate on all of this by drilling down and asking more questions. Okay, so can you tell me who made those changes? It's going to go out to Splunk and pull the logs coming out of Meraki. I can even go as far as, because I have access to Meraki dashboard via the AI, I can say, this is not acceptable. Fix config drift and update my network. And it's going to go out either to Splunk to get the old values from the log, or it's going to go out to NetBox, get those values, and it's going to go back down to Meraki and update my configuration. And as you see here, it went and it's updating my devices based on my source of truth. Imagine putting that in a true agentic motion where you have the AIs actually listening, where your hands off, all you're doing as an operator, just saying, getting the okay to go and update your configuration with human in the loop, right? So you can see how powerful this is. And all I had to do is just connect a couple of events back and forth in the different pieces in my network, and job's done. So everything I talked to you about here is available on Cisco U. We have plenty of all of the tutorials that to walk you through the steps of how to implement this on your end. I know I ran a little bit longer, so I really appreciate your time. If you have any questions, if you're looking to implement something on your side, come talk to me. I'm happy to help you. But hopefully you found this session informative, and thank you for your time. Enjoy the rest of your week. Thank you all for your time.
All right. Let's go ahead and jump into things. My name is Kyle Winters. I am a technical advocate with the Learn with Cisco team, and I take a focus on cybersecurity. I've been with Cisco on and off for the last decade or so. I came in through the acquisition of a company called Landcope and their product StealthWatch, actually thanks to that gentleman in the back right there. And since then, I've had various different roles across Cisco, including in DevNet, technical marketing. I went on to application security startups as well, and now I'm back as a technical advocate here focused on cybersecurity. So thank you all for coming today. This session is going to cover offensive security. So hopefully you're all interested in putting your ethical hacker hats on today, because we're going to jump into a lot of cool demos. I like to start though with a quote just to kind of set the tone. And this is from The Art of War by Sun Tzu. And it's, if you know the enemy and you know yourself, you need not fear the result of 100 battles. Many of us here today are focused on the defensive side of security. Maybe you're focused on infrastructure or networks as well too, but you still ultimately are helping build infrastructure that is meant to be secure. But how well can you secure these systems if you don't understand how the adversaries are going to attack them? So my hope here today is to show you a little bit of how the other side of the offensive side of things works, so that way you can take those skill sets and better secure your environments as well too. We'll start with just an introduction that covers the state of cybersecurity and teaming as a whole. And then we're going to spend a lot of time going into demos. I've got 4 demos for you planned today, and we're going to kind of give you an overview of each of these before we jump into it. But most of the time here today, we're going to spend inside of Kali Linux doing some actual hacks. And these are all hacks that you can do at home as well too, entirely free and available to you. And I'll talk about those resources for you here shortly. We'll wrap things up with a quiz as well too. Unfortunately, I don't have a prize for the winner of the quiz, but hopefully bragging rights and being the top ethical hacker here today is enough of an incentive for you to give it a good shot. So let's jump right in. But before we do that, a couple housekeeping items. There is a WebEx Teams chat that's available. You can join it through the Cisco Events app. I will be monitoring that until the end of the week. And if you have any questions or you want the slides from today's session, you can get them inside of there as well. Now, let's go ahead and jump into things. The cybersecurity workforce has grown significantly over the last 10 years. Studies show that about a 33% growth over the next 10 years is occurring. And if you take a look at the global workforce gap, there's 4.7 million cybersecurity jobs going unfilled in the last year. And that's actually up 19.1% year over year. Even more so in APJC is where the bulk of these lie. So this region that we're all in right now, 3.3 million jobs going unfilled in cybersecurity. And that's grown 26% since the previous year. So there's tremendous job opportunities and markets inside of the Asia Pacific region for cybersecurity professionals. Now, many people think cybersecurity, you got to work at a tech company. That's not necessarily the case. Cybersecurity jobs are everywhere, and there's always a need for them across every industry, whether it's transportation, healthcare, food, water, government. You don't need to be at a tech company to work in cybersecurity. Now, many people also think cybersecurity can fall into one or two buckets. When you think of it in a corporate sense, most people think of the blue team stuff. That's the defensive security side of things. That's things like running a security operations center, building secure networks, deploying firewalls, things like that. But many companies today are deploying red team or offensive security teams as well too. And this is really about testing the strengths and weaknesses of your organization before the attackers do. So being able to do the things that you see on shows like Mr. Robot, but in an ethical, sanctioned way, that you can then be proactive with your security posture. Roles like ethical hackers emerge from this. Other names for it can be things like penetration testing, bug bounty hunter, vulnerability assessor. But really, this is just about understanding how the business that you work for works and identifying the weak spots so that they can be fixed before an attacker gets in there and exploits them. Now, the challenge is when it comes to cybersecurity, you saw that workforce gap earlier. There is a significant gap. How are companies going about filling that gap? Well, first of all, 77% of them are just having a hard time finding the talent to fill those open roles to begin with. The way that they're trying to fill that, many of them, about 71% of them, are upskilling or reskilling their current workforce because they need to be able to fill that 4 million gap that exists out there. It's all about skills ultimately and having the right people with the right skills. And here at the Cisco Youth Theater, we want to help you get those skills and be able to better secure your environments. That's why we've introduced the Cisco Certificate in Ethical Hacking. This is available through Cisco Networking Academy. It starts with a free 70-hour course on ethical hacking, completely free, 70 hours with a built-in lab environment that's part of it. You'll learn a ton of cool stuff in there. I'm going to show you some of that stuff here today. But once you complete that 70-hour free course, you can come into Cisco U, that's u.cisco.com, and do a Capture the Flag challenge. And once you've completed one Capture the Flag challenge successfully after completing this course, you earn yourself a Cisco Certificate in Ethical Hacking, and you can go to your employer and say, I am certified in how to do offensive security. Now, I mentioned there's a ton of content in here, 70 hours, 34 labs. It's all self-paced, and it's all free on netacad.com. And one of the great things about it as well, too, is there is a lab environment that you can take. And I'm going to show you this environment here today. There's a version of Kali Linux that comes with it. And there's different types of lab hosts in there that you can try these different types of attacks on. So you don't need to build your own lab environment. You don't need to test this against your own business's infrastructure. You can just spin up this VM right here and have everything you need to start doing ethical hacking in a safe playground. So we're going to show you several different hacks and attacks that can be done and learned through this course here. The first one is called a man-in-the-middle or on-path attack. And this is a great way to essentially intercept the communications between two different hosts. The way that we're going to do this is using a tool called EtherCap, and we're going to do something called ARP spoofing. So we're going to broadcast what's called gratuitous ARP messages out across this network, and we're going to tell the host, hey, this MAC address for this IP address is actually the one of my Kali Linux host. There's not security protocols in place to check that, so it's going to assume and trust that data. And what's going to happen is when we try to communicate between these two hosts here, they're going to be intercepted by this man in the middle right here. And we're going to be able to read those packets coming in. That's going to be the first attack that we're going to do. The next one is a denial of service attack. Who's heard of a denial of service attack? Hopefully most of you. Hopefully you haven't had to deal with one in the wild yourself, but understandable if you have. Really, the denial of service attack is about exhausting some kind of component or resource on a system to make it unusable. We've heard of distributed denial of service attacks, probably. That's a very common one where you flood it with different packets from different hosts across the board. What we're going to do today is one called slow loris. And the way that this one works is instead of using a bunch of hosts, we're going to use one host. And that host is going to open up a ton of incomplete HTTP connections to a particular web service. Those connections are going to remain open, and the server is eventually going to become overloaded and not know what to do with this, and the services on it are going to cease to function. So with a simple Python script, we're going to be able to essentially halt the services on a server just by opening up and flooding it with HTTP connections that it can't complete and remain open. The third that we're going to do is password cracking. And we're going to use a tool called Hydra to do this. Now, it's fairly easy, obviously. Many people don't use secure passwords. Hopefully your password is not set to Louvre. Just a little warning there. But many people aren't using secure passwords. And these password cracking tools are a great way to essentially compromise the system and get a foothold in there. The way that Hydra works is we're going to feed it a couple different lists of words. One of them is going to be usernames that are commonly used. The other is going to be passwords that are commonly used. And it's going to try to use these different combinations of usernames and passwords until one of them is successful. You can do this. Today we're going to do this over SSH, but it works over HTTP, FTP as well. And it also has commands if you don't want to use a word list and you really want to brute force things to try every single combination of characters under the sun. Now, this will obviously take a long time to run if we use a full word list or try to brute force everything. So we're going to use an abbreviated word list here today, and I'll show you what that looks like. Now, the last thing that we're going to do is actually try to get into a system without even needing to use the password. And we're going to do what's called remote code execution. So we're going to use a tool called Metasploit. Some of you have probably heard of this tool. We're going to use this tool to essentially trigger a vulnerability on a particular FTP server. And when we trigger that vulnerability, it's going to allow us to have root access on that device. The vulnerability itself is called VSFTPD234 backdoor. And this is actually a really unique one because this backdoor was put into this version of VSFTPD, where if you put a smiley face in the username, it will essentially unlock a backdoor into that particular system. So the people who compromised this server thought it'd be funny. It's very easy to do. And with a tool like Metasploit, you can actually do it super easily as well too. But once we get in there, you'll see we'll have full root access on this particular system. So those are the 4 different types of attacks that we're going to cover here today. Now, before I jump in, one quick disclaimer. Everything that we're doing today is in a controlled lab environment. Don't go do these things on your employer's production systems later on. Don't go do them against your political rivals or companies that are competitors of you, whatever it may be. This is all meant to be educational And please do these things in an ethical, controlled way, because that's the whole point of being an ethical hacker, is doing things in an ethical way. If you do things in a non-ethical way, there could be severe legal consequences, and I will not show up for your court date. I'm sorry. But hopefully you find these things to be educational, informational nonetheless. So let's go ahead and jump right on into things. I'm going to go ahead and switch my screen here and pull up Kali Linux. Everybody can see that okay? Good, good. Let me just make this full screen here. All right, so the first thing that we're going to do is that man-in-the-middle attack using EtherCap. And we have two servers here. This first one is going to be one of our targets that we're going to attack, 10.6.6.23. And this one down here, that's our Kali Linux host. Its IP address is 10.6.6.1. And take note of its MAC address here as well, too, this 0EC3. We're going to essentially override the MAC address of different devices on the server that we're attacking and make it think that this is the correct MAC address for those other IP addresses. So let's just start going into that server that we want to attack. And let's just take a look at the ARP table there. And we'll see we have a couple different hosts. Here's our Kali Linux host right here. Again, you see that 0EC3. And then we have two more hosts up here, 10.6.6.11 and 10.6.6.13. And take note of the MAC addresses there as well too. One ends in 0B, the other ends in 0D. So we're going to go ahead and run this EtherCap function down here on Kali Linux. And we're going to do that just by starting with sudo, call it EtherCap -t -i for the interface. And the interface that we have on this host is BR internal. We're going to do the man-in-the-middle attack, and we're going to use ARP. And the first host that we want to attack on one side of the communications is this one here, and I forgot to put a slash here. You can put two slashes at the end there. If you want to specify a specific port, you can put a port in between those last two slashes. But if you just put those two slashes and leave it blank, it'll check for all ports. 10.6.6.13, and again, I forgot on the front side here. All right, so that should be our command there, down at the bottom. I'm going to go ahead and run this. And it should be up and running right now. So first thing we're going to do is let's just ping a host that is not part of this attack chain here. Ping 10.6.6.11. And you can see those pings are going through successfully. Nothing's happening down here on the bottom. Now let's take a look and ping the other side of the attack. You know, we have the two hosts that we're trying to intercept communications for. The second one was .13. When we ping it, we start to see those pings come in down here. So now we're essentially intercepting the traffic between those particular hosts there. Oops. And if you're doing things like HTTP or Telnet, you'll actually see those packets and the data coming in across there as well too. If we take a look now at that ARP table in that first host up here, uh-oh, what happened here? There we go. You'll see, take a look at this. That 10.13 host here now has the same MAC address as our Kali Linux host. So we were able to ultimately override what it was set to before. If we take a look and scroll up here, you'll see it. It used to be OD at the end. Now it's the same as our Kali Linux host. So those packets are now being rerouted to our Kali Linux host, and we're able to intercept them there. So that's the man-in-the-middle attack there. Very easy to do, especially if you have two particular targets that you're trying to intercept traffic between. And again, if they're using a non-encrypted protocol, you can actually see that traffic coming in, open it up in tools like Wireshark as an example. So next, I want to do the slow loris attack for you all. Let me go ahead and kill this over here. And again, that's that denial of service attack that we're going to do. Let me just start by scanning a particular web server over here, just to show you what's running on it. And this gives me a chance to talk about Nmap as well too. Nmap is a very cool tool to do network reconnaissance. You can scan for different hosts in different environments and get a lot of useful reconnaissance information on that particular host. So let me move this up here so you can see it a little bit better in the back. But if I run this command here, it's going to scan for the different types of services on that host, looking at port 80, because we want to look for a particular web service. We're going to specify port 80 there. And we can see we have Apache HTTPD running on that particular web service. And if we want, we can jump over here, log into it as well too. 10.6.6.14. And you can see there is indeed a web service running over here. So everything seems to be working on this web service. We can refresh it. It's coming back up. But let's go ahead now and do our slow loris attack. And let me just come back over here, exit out of this. So I have two terminal windows now. And I'm going to put a watch really quick on the communications between these two hosts. So it's just going to do a curl command every second or so. And you're going to see that this is, again, going to be working just fine. So you can see that curl command should be working. Yeah, and you can see every second it's updating there. That is essentially retrieving the information successfully from that web server for now. But let's go ahead and do our slow loris attack here. And if we take a look, we have in here a package called slow loris. And really, this is just a Python script. You can download this off of GitHub. And this is going to be what we use to do the slow loris attack. So I'm just going to go ahead and run this Python 3, slow loris.py. And we're going to specify the number of sessions to create at once. And that's going to be 500. We're going to specify the port, which is 80. And our target, 10.6.6.14. And again, before I run this, just to show you, everything's still uploading, refreshing here. We have these communications that are updating on the top here. When I go ahead and run this now, that stopped. We're no longer getting updated communications from this host. And if we come back over here on the right, that's just going to spin and spin and spin and time out. So essentially, just with the quick command in a Python script, we've stopped this server from being able to communicate with anybody or do anything. And again, we do that using the slow loris attack by opening up, as in this case, 500 HTTP connections at one time, keeping them incomplete and keeping them open. And by doing so, this server is basically non-responsive now. You can see still nothing coming in on the top here from that curl command either. So this is an example of a denial of service attack that you can do. Very easy, can be very mean to do as well too. Let's go ahead now and jump over to the password cracking one. And I'm just going to keep this running here for fun. But let's go ahead and kill this on the top here. And let's just jump over to our word list, and I can show you this. So I mentioned before that when you're doing password cracking, oftentimes you're using something called a word list. And this is a combination or a list of different passwords that can be commonly used. One that's very popular, actually, and used very often is called rockyou.txt. There's a ton of stuff in here. And if I was just going to cat this just to show you, you can see, oh my goodness, it's just going to keep going and going and going and going. There's so many things there. And if I just want to do like a word count on this and count the number of lines just to show you, 14 million passwords in this one particular file for somebody who wanted to try to crack something to try. Now, if I was to use this and try 14 million passwords, you guys would be here all week with me. I know you have other sessions that you want to attend, so I've made some abbreviated ones for us to take a look at here. And the first one is going to be top passwords, shortlist.txt, and you can see there's a few different passwords in here, much shorter and more manageable. And the other one that we're going to do is top usernames. And you can see again, shorter, more manageable. This will save us time for our demo here today. But let's go ahead and run this. And just to show you Hydra here again, You can just test this to make sure that's installed by running hydra-h, and you'll see there's some good examples here for you on how you can do different types of attacks with this. But let's go ahead and run it with our 2 word lists that we have here. We're going to do hydra-l with a capital L, because the capital L means we're using a word list file. If you do a lowercase l, you can specify just the actual username that you want to try it with. But we want to use a word list in this case. And we're going to specify for the username word list, top username word list. And then we're going to do a -P. And just like the L for login, the -P tells us we're going to use a word list for our passwords as well too. And that word list is going to be user share word list, top password short list. We're going to do a -T for, and that's going to tell us how many threads to run at the same time. So we'll do 4 at the same time. And -f, which means once we find one match that works, we're going to quit out of it and give you the results. So let's just do this, SSH 10.6.6.23, and let's run it. So this is going to go ahead and run now. It's going to try those different combinations of usernames and passwords to try to SSH in to this particular host. And once it finds one that actually works, it's going to print this out on the screen for us here, just like this. So we see here our host 10.6.6.23. Our login was lab user, which actually worked. And the password for it was Cisco 123. And we can go ahead and test this. Let's just go ahead SSH in as lab user at 10.6.6.23. And we're going to give it the password Cisco 123. And we're able to get in. Super easy, just like that. All you need is one command and some patience if you have a long word list to work with. So that's how you can get into a system, compromise it when you need to know the password. But as I mentioned before, there's ways to get into systems and do things like remote code execution without even needing a password to begin with. And a great tool for that is actually Metasploit. So we're going to do that one particular FTP vulnerability, that backdoor one, and we're going to use Metasploit to do that. And just to show you first that we have a server with that particular version of FTP running on it, you can do some reconnaissance again using nmap-v, and it's going to be port 21 for FTP. And we'll look at this particular one, 172.17.0.2. You can do a scan of an entire subnet as well too if you'd like, but just to save some time here, I already know the IP address and I'm specifying it here. So we can see VSFTPD version 2.3.4. That's the one that we know has a particular backdoor. But in case you don't know and you just want to investigate a particular server and you see something like this and you want to know what vulnerabilities and weaknesses exist for it, you can actually run this nmap script here as well too. Nmap-sv, again, specify port 21. And you can do what's called nmap scripts. And this is a great, easy scripting language that's built into nmap. And there's a script here called vulners that will actually scan and tell you the vulnerabilities that are associated with that particular version of that software. So in this case, make sure I got this in here right. I'm going to go ahead and scan this host again, but I'm going to put it through a script, that vulner script. I'm going to look for things that have a minimum CVSS score of 9. And there's that IP address. Let's go ahead and run that. So what it's going to do is it's going to look up that particular version. It's going to go ahead and then check for different CVEs associated with it and give me the links to those CVEs. So you can see those CVEs coming in from here up top. And if we take a look, we have some ones that are 10s, 9.8s as an example. And we can come click in on any one of these, get more information. It should open it if I click this right inside of here. And we can see more details on that particular vulnerability. I guess it needs to verify I'm a human first. And we can see different vulnerabilities in here as well too. So obviously there's several that are associated with this particular host, but we're going to focus on just one here, and that's going to be that Metasploit one, or that VSFTPD 2.3.4 backdoor. So let's go ahead now and open up Metasploit, and you can do that with this command msf console. and it's going to go ahead and launch Metasploit. Every time it launches, it actually loads kind of a different graphic here, which is kind of fun. We got actually not too exciting of one today, but sometimes they are a bit exciting. Metasploit has a ton of different exploits built into it, though. The idea is for penetration testers and ethical hackers to be able to do these things and automate them with ease. Unfortunately, malicious people use it too, but we are ethical here today, so we're going to use this in an ethical way, of course. Just to show you, though, you can come in here, and right now, just even looking at exploits, 2,335 different ones here. We're going to test it on a Unix system first, so we can come in here and say Unix, FTP, and again, even just looking at this, there's a few different options here, but the one that we want to do is this VSFTPD234 backdoor. So we're going to use this exploit. It's going to jump into the menu for this particular exploit, and there's some options that we need to set, actually just one in particular. But you can do the show options command, and it'll list the different options that are here. In this particular case, there's just one that we need to set, and that's our host. That's the remote host IP address. So we can come in here and say set our host 172.17.0.2. And now that is set, and you can see that up here as well too. That is now set. So we're ready to go. Let's go ahead and run this now. And one thing I've noticed actually is when you run this the first time, it tends to not work. So you'll see it's going to ask for a password, yada, yada, yada. It's going to time out here in a second. But when I run this again, we're going to have root access into this particular host. So let's go ahead and run it again. And you can see now we are logged in as root. The UID is root. I can do something like who am I? It's going to go ahead and say I'm root. If I want, well, I can say config eth0. And you can see again we are on that particular host 172.17.0.2. So with just a simple couple clicks here, I was able to get root access into this particular host, and now I can do whatever I want on this particular host. So very easy, very straightforward to do. And again, this and many of the other things that I have showed you here today are available with the Cisco Networking Academy course. How do I escape out of here really quick? All right. Oh, I forgot how to quit out. There we go. So hopefully that was interesting for you all. There's a ton more you can do, again, with this Cisco Networking Academy course. 70 hours of content, tons of stuff in there, including things like the social engineering toolkit, SQL injection attacks, all sorts of stuff in there. You complete the course, it's 70 hours, it's completely free, and you do one capture the flag challenge, and you have access now to the certificate in ethical hacking from Cisco. Now, again, if you're not familiar with Cisco U, that's where you can do those capture the flag challenges. It's the namesake of this particular theater here. So you can find out more information on that over here with one of our folks in our booth. And if you want to learn more about NetAcad as well too, or even become a NetAcad instructor, come see my colleague Lynn. She'll be around here as well too to help you out. But without further ado, I know we're getting short on time here. I did say there was going to be a quiz at the end, and I'll go ahead and pull that up now so you can all join. Now, there's going to be 5 questions. You're going to have about 20 seconds to answer each question. If, let's say, multiple people get all the answers right, it's going to be whoever was the quickest to complete the quiz will be at the top of the leaderboard. So go ahead and jump in. That QR code's up there now for another few seconds. Start to see some names coming in here. All right. Anybody else still trying to connect? Everybody good? One more. All right. Let's go ahead and begin with the first question. What is the primary characteristic of a man-in-the-middle attack? The attacker directly floods the victim's system with traffic. The attacker intercepts and potentially alters communications. The attacker gains physical access to the victim's device, or the attacker uses social engineering to trick users into revealing passwords. 1 second left. And let's see those results. 97% of you guessed correctly there. It's that second one, essentially sniffing that communications in between those two particular hosts. Next one, how does slow Loris primarily conduct a denial of service attack? This is the one that I showed you earlier. Is it by sending a massive volume of data and packets, exploiting a vulnerability in the operating system, keeping numerous HTTP connections open, or performing a brute force attack on the server's login page? 3 seconds left. All right, 76% of you guessed correctly by keeping numerous HTTP connections open. It sends those incomplete requests. It keeps them open. The server becomes exhausted and doesn't know what to do. Next question, what is a primary advantage of using a word list or a dictionary attack in password cracking? Is it to be able to crack any password, eliminate the need for the username, work on systems with very weak security? Which one of these is it? You guys all can read it. It is that top one right there. It's got that list of commonly used words, passwords, usernames, and it's trying to use those ones that many people commonly use as well too. 2 more for you. What was the specific trigger for the backdoor remote code execution vulnerability in BSFTPD 2.3.4? There was a specific trigger, something that you could do to make that attack work. Which one of these things was it? You're all paying attention. Hopefully it's all smiles across the board, because the correct answer is smiley face in the username field. That's that little trigger that the attackers left in there. All you got to do is put that smiley face in the username, and that's how you get that backdoor access. Last one, how is the Cisco certificate in ethical hacking earned? Is it by completing the free course and passing a written exam? Please don't say it's by hacking me. I would appreciate it if you don't hack me. Was it a 5-day boot camp? Or was it the free course and at least one capture the flag challenge? Hopefully you all get this one right, and hopefully nobody tries to hack me later. And that last one down there is correct, by finishing that free course and completing at least one capture the flag challenge. So without further ado, our winner is D. Where's D? D. 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 Congratulations, D. I have high fives for you, and if you find me later, I can get you a beer as well too, maybe. But that's it for you all today. Hopefully this was informational. Please fill out your surveys. Fives are appreciated. And enjoy the rest of your time here as well at Cisco Live. And if you want to connect with me as well too, you can add me on LinkedIn. I'm happy to continue the conversation there as well. Thank you all again so much. I really appreciate it.
Okay, welcome everyone. It's time to start. So I'm going to dive right in because I have a very bad habit of running out of time. There's too much I like to share. So I want to make the most of every second allocated for me. My name is Tim Seghetti. I'm a distinguished engineer, been with Cisco 27 years. I lead Quantum Ready Services. We're going to talk briefly about that. But first, the overall intent of this session is to understand the quantum threat. You've probably heard of it. You've read about it. There's a lot of fact, fiction, hype, exaggeration. How can we sift through all that and really understand it? And to do that, we need to look at and understand 2 key algorithms, Shor's algorithm and Grover's. To understand that, we have to understand the basics of quantum computing. To understand that, we have to have some familiarity with qubits, quantum bits. So there's a little bit of foundational context that we need to set, and that's the intent of the next half hour. By the end of this half hour, it's my goal that you'll be able to answer these questions, these 5 key or 6 key questions. including what makes a quantum computer so fast? Is AES under threat? Why or why not? Is RSA under threat? Why or why not? What's Y2Q and when is it expected? What are 3 key requirements to becoming quantum safe? And then when, per the Australian Signals Directorate, is it being recommended that all networks here be quantum safe? Okay? That's my goal for this session. So I'm going to start by just introducing quantum computing at a high level. This is an ultimate crash course. So let's start with how we do digital computing. Digital computing uses various means of representing a logical value of 1 or logical value of 0. The method that's the cheapest, the most scalable, and most reliable is a transistor. It wasn't the only method. Years ago, we used vacuum tubes, we used electromechanical devices, but the transistor is definitely one out as for all of those reasons. And then transistors, we just combine into more and more complex circuits. That's all we do for digital computing. Does anyone have an iPhone 17 Pro by any chance? Okay, so he has an iPhone. You have it with you? So the gentleman here has got 19 billion transistors in his hand. That's how we scale digital electronics. We just make more and more and more transistors in an increasingly dense space. These transistors then we combine into logical circuits that we call gates. For instance, this is an expression of the not AND gate, abbreviated as NAND gate. When we study computer science, we're introduced to 3 basic gates, AND, OR, and NOT. Those 3 gates form what is called a universal gate set, which means you can implement any expression of Boolean logic with those 3 gates alone. You don't even need anything else. There are more gates, but that's really all you need. And to be very technical, actually all you really need is just a single NAND gate. From a NAND gate, you can do all 3 of those, which means you can do any. And that's how they're ultimately implemented. And then what do? We just combine gates and increase the complexity of logical circuits. This is a 2-bit adder circuit, part of a calculator. And then we just make these circuits more and more complex, and then they have greater and greater capabilities. That's all we do. That's the magic. That's the underlying principle of digital computation. Yeah? Okay. So then how do we translate that to quantum? Well, with quantum bits, we have various modalities. For instance, we can use subatomic particles that are electrons, photons, neutral atoms, ions, any one of these modalities. And they're going to have a state that we will say represents logical value of 0. In the case of an electron, we look at the spin of the electron. And it's not a physical spin. I'm just using physical spin to illustrate. The action is basically the magnetic fields come from the top, the North Pole, and go south. Or vice versa, South Pole go north, or anything in between across any 3 axes. Okay, so for instance, we have, when you think of an axis plane, right, we have X and Y. X is lateral, side to side. Y is up and down. To go from 2 dimensions to 3, imagine if I took this 2-dimensional Cartesian coordinate system and I slid it directly through the center of this tennis ball. So the x-axis would be side to side, right? So if I rotate, let's say I start at the North Pole, and I rotate 180 degrees along the x-axis, I get to the South Pole. Yes? So North Pole, logical 0. South Pole is logical 1. That is the equivalent of a NOT operation. So if I circle around the X, I get NOT wherever I started. If I started at South Pole, I come, which is 1, I come up to the north, 0. It's the opposite. I can do the same thing by rotating around the y-axis. That's the front dead center, or the back dead center, however you want. Imagine again, I'm at the South Pole, I rotate around 180 degrees, I get down to from the north to the south. But I'm going to be facing the other direction. So think of it, I'm a tiny little person on top of the North Pole. If I rotate the x-axis, it's like going forward, and I get all the way to the South Pole, I'm facing the other direction. if I rotate around the y-axis through the center, I'm going to tilt that way, and I'll get to the bottom, but I'll be facing the same direction. That's called a shift in phase. Okay? So we can rotate around any axis, X, Y, or Z. I don't have to do a full 180-degree rotation. I could do a quarter turn. And that's important because then I can combine these rotations to get to any arbitrary position I want. And this is an important gate too, this H gate that basically says whether you start at the North Pole or start at the South Pole, you're going to rotate again around an imaginary axis that's halfway between the equator and the North Pole, and you're going to end up exactly on the equator. You start at the North Pole, you end up on the equator. You start at the South Pole, you end up on the equator. So this is a brilliant way to reset a quantum circuit, to initialize it. You're always going to see that Hadamard gate, that H gate. And the final key gate for this universal gate set is called controlled knot. That basically entangles electrons, and we'll see that in operation in just a moment. Okay? So if I start with an X gate, again, I'm just rotating around the x-axis, the lateral axis, from the North Pole to the South. It's a knot operation. And if I do the math, this is how it all works out. I had to actually do a refresh of linear algebra. I had to get my son's, my high school age son, I had to ask his math tutor to please take me through again matrix multiplication, linear algebra, because I'd completely forgotten it. But that's the math involved. And incidentally, here's an interesting trivia point. This is exactly the core mathematical function of AIML, or neural networks. It's all matrix multiplication. That's why GPUs excel at AIML, because that's their best function, changing vectors, distance and direction, and that's the operation. And this is also why quantum is particularly suited to advance AIML even further, because it natively performs this operation at the gate level. The other gates, similar kind of operations. The Hadamard, this is a Hadamard gate that I talked about that initializes. Whether you start at the South Pole or North Pole, you're going to end up on the equator. A 50-50 probability of 1 and 0. And there's some math behind it. Okay. Now, one final gate is the controlled NOT gate. Now, how many are familiar with the XOR gate, the exclusive OR? Okay, let's take that as a starting point, as an analogy, a reference analogy. So with the XOR gate, the two inputs have to be different for the output to be 1. If they're both 0, the output's 0. If they're both 1, the output's 0. But if they differ, then you're going to get 1 out. Okay? Now, here's the thing with quantum gates, is that you always have to have the same number of inputs as outputs. With digital circuits, we have 2 inputs often and 1 output. You can never have that with quantum. It has to be the same number, either a single qubit in, single qubit out, or 2 in, 2 out. That's a requirement. So what we're going to do is imagine if I just tap off that input and include it in the output, and I'm just going to copy that same column here. Is copied identically to here. Okay? Now, what I want you to take a look at is what is the output of this gate if input A is 0. How does the output compare with B? How does the output compare with B when A is 0? Same, right? How does the output compare with B when A is 1? It's the opposite. It's not A. Okay, and this is what causes an entanglement that says, okay, at this point, A controls the NOT operation for B. When A is 0, nothing happens to B. When A is 1, it will flip, do a bit flip on B. Yes? And then this is a truth table for it. You've understood now the universal gate set for quantum computing. You can design any circuit of Boolean algebra with quantum gates. The presentation should be within the apps. If not, I'm also going to put it in the WebEx room. Okay, so I'll make sure you have it. If not, feel free to email me my last name at Cisco. And then basically, to create quantum circuits, you just combine more and more of these gates to express whatever Boolean logic you want. Yes? Okay. And incidentally, you can use tools like IBM's Quantum Composer, and then you just basically to implement an H gate, you say, okay, I'm going to have an H gate on Q0. There it is. I'm going to have a controlled NOT CX gate that's between Q0 and Q1. So Q0 is the control, Q0 is what's going to be flipped, and so on and so forth. And then I measure. It's relatively straightforward. This is called quantum assembly language. It's not that hard. It's actually a lot easier than learning the math. I struggle with the math, but the programming is pretty intuitive. Okay, so then what makes a quantum computer so fast? Two key things. First is parallelism. Because of a property called superposition, we discussed that yesterday, where basically a qubit can be not just at this north pole or south pole, it could be somewhere in between along any axis. And we can perform operations on it in that state, which means basically we're performing operations on a probability of 1 and a probability of 0 simultaneously. That's powerful. That means that I can basically, what I could do in digital circuits that required me 2 bits, I can now do on a single qubit. And then every time I add a qubit to my system, I double that overall capacity to operate simultaneously, and I become more and more powerful, more and more faster. And so this is how every time I add one, I exponentially increase in my computational capabilities. Does that make sense? Okay. Now the other, and that's a little bit less known and understood, is called interference manipulation. These particles have a dual nature. They behave as a particle, subatomic particles behave as a particle and as a wave. They have wave-like properties. And with waves, I can combine waves in a way that will be additive. If they're in phase, 2 waves, if I'm combining them exactly in phase, they become really large. I think of like when my kids start bouncing on the trampoline and they time their bounces to synchronize, then suddenly they're nearly on the roof, right? So it gets very big. On the other hand, you could also have what's called destructive interference, where 2 waves are out of phase. And then when they're combined, they essentially cancel each other out. This is how your noise canceling headphones work, the same principle. They sample ambient noise, they reverse the phase, and then they play it, and then you have this eerily quiet effect. So that's called destructive interference. And so basically the way that these algorithms are optimized are so that when you have an answer that meets the truth conditions, you want it to amplify its amplitude, and then that squared represents a probability of that final output. I cover this math in the session later on this afternoon. Just don't have time to cover it here, but basically you can manipulate so you have a higher probability of getting to the right answer and lower probability of getting to the wrong answer by manipulating that interference. Okay, so what does that mean to problem solving? Well, rather than classically checking every solution one at a time, I can do much fewer passes and get to a probable solution. And then if I rerun it, I'll increase the probability of the right solution again, and I'll get there much faster, much fewer iterations. I do not have to be exhaustive on that list. We're going to come back to this because this is how basically Grover's algorithm works. We're going to see that. Now, the other thing to recognize is quantum computers are not necessarily better at everything. In fact, they're not. Let's just put it that way. They're not. There's about 4 key things that they're extremely more powerful in: simulation, optimization, AI/ML, and decryption. There may be some more than that, but those are the 4 primary ones that exhibit the greatest advantage. So what does that mean when we say quantum speed up? Well, when all these advantages are combined, superposition, interference manipulation, etc., then we could have an accelerated capability for a quantum computer versus a regular one. That may be as simple as a linear advantage. That's not very impressive. Or something more impressive is when we get a quadratic advantage, squared. Basically, we're doubling the efficacy of it. Or in the case of minimizing errors, we're doing a square root of the errors. You know, one depends on the direction that good is being represented at. But the real holy grail, the ultimate, is when we get an exponential advantage, to say 2 to the x. And every time that we add x, which is representing another qubit, we've doubled our capabilities. It becomes extremely powerful. And if we change and we stretch out the y-axis again, you'll see the difference between exponential in purple, quadratic in yellow, and linear. It's negligible. Okay, that's important to understand the distinction between exponential and quadratic, okay? Does that make sense? Okay, now we're about to circle back to that. It's directly relevant. So then, how much faster is a quantum computer? Well, about 4 years ago, and I'm going back on purpose, 4 years, because otherwise it's hard to, I could say a really big number and it'll be so large that it just becomes meaningless. But I think this is an interesting example, because if this particular computer at 127 qubits was rated as 158 million times faster than its classical counterpart. So imagine this. What was going on in the Earth 2,500 years ago? I asked this of my wife, who is Greek, and she told me that the biggest thing happening was that the Greeks were in their golden age, building the Acropolis, the Parthenon, inventing mathematics, medicine, philosophy, democracy, and all the other things that the Greeks are famous for contributing. And they're very happy to share that with you. So imagine, at the time they're building the Parthenon, you kick off a computer job. That job is running and keeps running. Rome hasn't even appeared on the scene yet, but then it does. It lasts for about 1,000 years. And then it crumbles, and then you have Dark Ages, then you have the Renaissance, and then you have everything until the modern era. That same job, 2,500 years to execute, would take you on a quantum computer 1 minute. That's the kind of exponential advantages we're talking about. And that was, again, based on technology that was 4 years old, the IBM Eagle. And then every time you add a qubit to that computer, it again exponentially increases its parallelism. This is a computer we just talked about. This number, does anyone know what this number represents? It's a baseline. It represents the number of atoms in the entire universe. And then this is where we are now. So we can simulate and compute on more states than there are atoms in the universe on a quantum computer. It's sheer mind-boggling. Okay? Now, with all of that foundation now laid, what does this actually mean, and what implications does it have to cybersecurity? So there's 2 key algorithms I mentioned we're going to look at. One is Grover's algorithm, an Indian American who did his master's at Stanford. And we're going to look at that one first, and then also Shor's algorithm. Both of these were invented in the mid-90s. Shor's was 1994, Grover's was 1996. Peter Shor, by the way, is a professor at MIT. He's actually done a lot for quantum computing. Okay, so let's look at these in turn. Now, incidentally, you might just see certain terms that we've already defined. And that should start having a real insight as to which algorithms we should be particularly scared of. This is what Grover's looks like. We've covered already every gate on this diagram. It's not that complex. The purpose of this diagram is to do an unstructured search. So in this case, I have 4 qubits, which represent 16 possible combinations, and I'm looking for a red ball in 16 boxes. I'm looking for a hit on a specific whatever I'm looking for, and I need to search 16 different places to find it. Okay, it happens to be in box 5, whatever. But with a regular machine, I'm going to have to do, at worst case scenario, up to 16 searches. One, is it in here? No, I check the next one. Is it in here? No, I check the next one. That's my worst case. With Grover's, I do square root of n, where n represents the number of possibilities I'm searching for. 16 boxes, square root, I need only 4 passes. That's all I need. And so here's how it looks like. It uses interference manipulation. Basically, I initialize a circuit with a Hadamard gate. So everything is set to equal probability between North Pole, South Pole. Everything's on the equator, 50% probability of working out to a value of 0, 50% probability of working out to a value of 1. I run one pass, and then the truth condition, the conditions that I'm testing for, the logical condition that will reflect whether or not it's in a particular location, the probability of the correct answer is amplified, and the probability of the wrong answers have been simultaneously reduced. I run that again. It happens even more. It exaggerates even further. I run it 2 more times, and I'm getting well over 90% probability. And the final answers are always probabilities. You're not going to get an absolute answer with quantum computing. You're going to get probabilities. And then you run the same test a few times, and that's one way you can ultimately get to that truth. But this is how they work. Make sense? So I had to run that 4 times. So then here's a question. How many qubits do I need to break RSA and AES? RSA 2048, a researcher this year published a paper that says you can do this with 1,600 logical qubits. I'm going to come back to that term in just 1 second. Whereas earlier estimates for AES says you need 6,681 logical qubits. So wait a sec, what is the difference between a logical qubit and a qubit? Why do we include that term logical? It's because these qubits are very susceptible and prone to errors. And as such, we need systems of redundancy to detect those errors. And one way that they do it is just have multiple parallel fault-tolerant circuits. A lot of redundancy. A simple example, if you wanted to find a single bit redundancy, you would copy the value 3 times, copy the entire circuit 3 times over, and then you'd compare the answers. And then the majority would define if there's been an error in the one. If one of these didn't add up and come out the same way as the other, well, the majority of 2 would indicate that single failure. But that's only a single bit failure. What if you had multi-bit failures? And therefore, you have more and more complex circuits to get to a fault-tolerant quantum computer, to create a fault-tolerant or logical qubit. But what's really interesting is the number of physical qubits keeps coming down to represent a logical qubit. So for instance, 2 years ago, Google, they said, okay, we can do it in 49. Then IBM later that same year, no, this was fun. In 2024, 2023, they got 49, but then later in the same year, Harvard did it in 48. And so there's kind of like this neck and neck racing that's going on. IBM then have that the following year, and it just keeps coming down. So now with that in mind, let's circle back and say, okay, well then how many qubits, physical qubits, do we actually need to, let's start with AES, Advanced Encryption Standard. And then based on the latest paper, he uses 561 to make a scalable solution. I'm going to use the same. You multiply that together, you're going to need about 3.7 million physical qubits to crack AES. Okay. But it's a big but. And the but is that, remember, Grover's algorithm is the one that can be used to crack AES because it's an unstructured search. I'm just looking for a key. And the key could be any one of 2 to the 256 combinations. And if I got to find that key, I have to do all these passes over and over again. And they cannot be parallelized. They have to be done serially. And even if I could do those passes in an absurdly quick time, 1 picosecond, 1/trillionth of a second, to crack that would take 391,000 times the age of the universe. So do we got to worry about AES? No. It's absolutely impractical, but you have to understand not just the relationships of how many qubits you need, the impact of error correction, how many physical qubits, that the logical qubits, but then what kind of speed up are we dealing with? Is it quadratic speed up or exponential speed up? If it's quadratic speed up, it's still safe, and it's going to be safe by the time all of us and everyone we ever know, like thousands, hundreds of thousands of times the age of the universe. You're not going to worry about it. Okay, so now let's look at RSA. RSA requires 1,600 logically corrected qubits. And then when we multiply that together, and his latest paper, this was Craig Gidney that published this in May or June of this year, he said you can do it with 864 physical qubits. Now here's an interesting piece of trivia. He published the same style of study 6 years ago, right? And you know what he said 6 years ago you needed? 20 million qubits. So in the past 6 years, he's gone from 20 million to less than 1 million. That's the kind of advances we're seeing in this field. Okay, but that's still a big number. We have to recognize that now we're dealing with Shor's, and Shor's algorithm optimizes what's called factorization. With public key encryption, what we do is we take two numbers, a public key and a private key, and you multiply them together to have a galactically large number. If you start with that galactically large number and say, what were the two numbers multiplied to create it? What were the two prime numbers multiplied to create it? That's a very difficult problem for digital computers to solve. But his algorithm solves that exponentially faster than any of our current computers. And then, not only that, but the number of qubits in our computing systems are increasing, so the parallelism becomes even more powerful, and the number of qubits we need for error correction keeps coming down. Remember, 6 years ago, 20 million qubits, and then this year, less than 1 million. So then, when can we expect this threat? This threat, incidentally, is called Y2Q. So it's years to quantum. It says, how many years till we have a cryptographically relevant quantum computer, a CRQC, that becomes available and your traffic can be cracked? And we're going to answer that, or we're going to give you some answers on that. But it's not even a threat a few years down the road because of this style of attack that's called harvest now, decrypt later. I'm going to grab all the traffic across this wireless network, or I'm going to hang out outside of your parking lot, or I'm going to monitor all the traffic in, across other networks, wherever I can tap into. I can't read it. I can't read it yet, but in a few years' time, when I have this, I'm going to break it all. I will get your secrets way faster. Just by having that storehouse, that trove of information. So how far off is this? Remember, we need about 1 million qubits, right? Well, look at it, say, IBM's roadmap. They say by 2029, they're going to have 100 million gates. IonQ says by 2030, they're going to have 2 million logical qubits. Google has a milestone that has 1 million logical qubits, milestone 6. They're all targeting around that same time frame. And if you ask experts how many years till Y2Q, depends who you ask. I love these guys. Cloud Security Alliance, very bold. I will tell you the day that that computer becomes available, April 14th, 2030. Various global risk institutes, they're a little bit pushing things off. They say, about 15 years. And then the politicians, well, they give like a politician's answer. But it's interesting that even though the White House just says, not too distant future, they've mandated all networks, all federal networks, to be quantum safe by January 1st, 2030. That's 4 years, 1 month, and 18 days. All of them. And if you're doing any sort of business with the US government, you have to meet those requirements. So even though they give a soft answer here, they've set some very hard deadlines. Well, then how do you make yourself quantum safe? Well, you have to use different cryptology. Instead of cryptology based on number factorization, multiplication and factorization, you need different approaches. Lattice-based mathematics is the core of several of these latest post-quantum algorithms. And what's really interesting is that one of these algorithms was cracked, even though it went through so many rounds of review, so many rounds of testing, and then they say, oh, there's actually a way that you can find a back door and crack it with relatively lightweight materials. The point being is that we don't know what we don't know yet. There may still be some of these ciphers that have vulnerabilities that, because they're being so rapidly developed, we don't know if they have some vulnerabilities that may emerge in time, or if there's new quantum algorithms that are going to be discovered, and therefore new types of mathematics that will be exponentially more efficient on quantum machines. We just don't know that. So we really have to be cryptographically agile, which we're going to talk about in just a moment. Another approach is to actually use quantum technology to protect us from the quantum technology threat. So quantum key exchange is actually something that's been deployed around the world. When China has like a 1,500 kilometer QKD network, various financial centers around the world, London, Geneva, Singapore, they have these QKD rings in their networks, basically to distribute keys in a mathematically proven safe way using these quantum networks. Now, there's 3 key requirements to be quantum safe. This is important to understand. First of all, you have to secure those communications. And this is basically, you have an indirect threat here, right now, because of the harvest now, decrypt later. If you have company secrets, proprietary intellectual property, trade secrets, etc., that's still going to be valuable in a few years' time, then you really want to make sure you start locking down your communications ASAP. Additionally, you have to protect the products themselves. Their digital identities, how are they signed? Are they using PKI? What about the software? Can you verify who wrote that software? Are you actually using the vendor-supplied software, or has there been a software supply chain attack? The runtime, all of these elements also have to be secured. Otherwise, you're opening yourself up to a Salt Typhoon type of advanced persistent threat where others can take control of your infrastructure. And then finally, as I just mentioned, we don't know what we don't know. These are all in a state of rapid evolution. You have to be able to adapt quickly and efficiently to the changes that will become manifest as we go forward. That being said, there's not a single there's not a single path to quantum safety. There's actually multiple paths. Just like when you have like a GPS app that says, hey, you can get from A to B. You can take, the fast way, the toll-free way, whatever, the commuter train way. You have all these different options. We can help people through any of these options. They all have their plus or their pros and cons, etc. But this is basically what we're working with people to do. So finally, how urgently does this have to be solved here in Australia? Well, like I say, the Australian Signals Directorate has said by the end of 2030. You should start making your plans this coming year, and you should have them fully implemented by the end of 2030. So it's about 1 year after the US. Okay, that being said, and this is what we're offering, people, and this is what I'm leading in Cisco and Quantum Ready Services. Okay, quick rounds of reviews. Hopefully you took something away from this session, and we're going to see if we did exactly that. So what makes a quantum computer so fast? 2 key things. Shout them out. Parallelism, good. What's the other one? Interference manipulation, excellent, I love it. Okay, do quantum computers threaten advanced encryption standard? Why or why not? So first of all, this first part, do they threaten AES? Yes or no? Who says yes? Who says no? Good, good. I feel really glad because that's a key takeaway. Absolutely key takeaway. Why not? The second part of the question. Why not? Grover's algorithm and it will take too long. It's only quadratic speed up. It will take up nearly 400,000 times the age of the universe. Do quantum computers threaten RSA, Reverse Shah Alderman? Yes. Yes, absolutely. So you only need less than 1 million qubits. You have Shor's algorithm, which is exponentially faster than digital computers. The number of qubits per computer is increasing. The number required for error correction is massively decreasing. Remember, 20 million 6 years ago to like 1 million today. What is Y2Q? Nice. When do most experts expect it? Yeah, 2030, April 14th, if you're with the Cloud Risk Institute. And then what are 3 key requirements to be quantum safe? This is really important. I hope you get taking this away. 3 key requirements. Shout it out. Communications, locking down those communications. That's the first and foremost. You're at indirect threat right now because of harvest now, decrypt later. Also protecting what? Platforms, great. And finally, crypto agility. As these evolve, we may have to change and expand, etc. And final question, when do Australian networks need to be quantum safe? End of 2030. Love it. Thank you so much for taking the time. It's very clear that you've taken something away. That makes me very happy. Enjoy the rest of the show.
Okay, we're going to get started. So thanks for joining. If you joined or registered for this particular session, I'll make sure that I drop the updated PDF to it. That's got the list of slides or the list of sessions I recommend that you capture either the rest of this week if you haven't attended those sessions, or you can catch them the recording on siscolive.com later on. We're going to get into MCP for DevOps. And there's been a lot of MCP sessions already. I mean, if you went to Kareem's talk earlier this week, he definitely is laying the groundwork for MCP, but there's a lot of MCP discussions taking place this week. And you're going to find out, if you haven't learned anything about MCP so far, why that is. MCP is definitely a hot topic going on both within the AI space, but certainly in the ops space, because it really closes the gap between things that we want AI to do for us and things we want to get off of our plates as operators or network or security admins. Okay, and so we're going to kind of lay a foundation here, specifically in the DevOps space. My name is Shannon McFarland. I lead the Cisco DevNet organization, which is the developer relations team for Cisco, and I also lead the open source program office. So all of the open source contributions that Cisco makes to Linux Foundation, Bytecode Alliance, all those other things from a program point of view, those flow through our group. So a quick look at our agenda here. We're going to do a level set on model context protocol for those of you that have not attended Kareem's session or one of the other sessions that we had. We're just going to do a level set of it. We're going to get into the architecture. It's a client server architecture. Talk about some of the core components of model context protocol. And then we're absolutely going to cover the communication mechanism. What does MCP look like on the wire? So this is not something that you very often see in YouTube videos or other sessions. They're all talking about how do you turn it on inside of your IDE, or how do you plug it into specific tools. We're going to cover those things as well. But I think it's important that whenever we're lighting something up new in our environment that we don't fully understand, it's really good to know what it looks like when it touches our networks, right? And so we're going to talk about the communications a bit. We're going to touch on use cases, but you'll have the full PDF. There's a lot of extra content in the PDF that you'll have available to you within the app or on the website. But we're actually going to walk through a fairly involved live demo in here, hoping that it keeps up with my internet connection from here all the way back to California, where some of these things are running. But we're actually going to talk through some use cases from an operator-centric view of the world through our demo. So how many people here, can comfortably raise their hand that they know a little bit about model context protocol? Okay, not a ton. Okay, so model context protocol is a communication protocol, which means it's plumbing, that has been brought to us by the Anthropic organization. So Anthropic being one of the foundational AI providers out there, they realized that lots of people were trying to link together large language models or small language models into tools such as APIs, such as databases, things that may or may not have any awareness of AI whatsoever. And so we've been doing this for a while. We call this function calling or tool calling. But it really was wrapped around the specific large language model that you were using. There was no standard way of getting that done. So if you had lots of large language models with lots of tools, you were doing lots of glue code work to stitch these things together. And so Anthropic kind of donated model context protocol, and context and protocol are the two key words there. And we're going to work through why those are the key words. But it is basically that glue code. It is a standard way that we can link your large language, small language models, whatever they are, to your existing tool sets, APIs, web servers, databases, GitHub repos, CI/CD pipelines, whatever it is. And we can do it in a standard way so that we're not constantly reinventing the wheel on getting that done. And we would use this practically in what the MCP spec calls an MCP host. But this is just an AI application. This could be your AI-enabled IDE. So it could be VS Code with GitHub Copilot, right? That would be an application. It could be a chat interface. It's Chat GPT. It's Claude, whatever it is, that you can link together these tools and connect to them. But at the end of the day, this is all it does. It is not discovering what the tools are. It is not helping you connect to other agents to figure out how other agents can help you. It is literally an intermediary, literally in the code. It is a proxy between an AI environment and passing that context to and from tools that do not natively understand AI. So from an architecture point of view, it is a client-server architecture. And so if we kind of look at multiple MCP clients that would be inside of your AI application, they will have a one-to-one relationship with an MCP server. And you can have large numbers of clients talking to large numbers of servers. Each of the providers out there that have already built an MCP client implementation will generally have recommendations for how many of these are safe to run in their environment. So, for example, if you're running Cursor, like I'll be showing in the demo, they'll basically limit things, in the 20 to 40 tool range with between 20 to 40 servers, right? Because you don't want to convolute the context with large numbers of servers that have large numbers of tool calls, right? It just really confuses the large language model. So each one of the folks that are out there leveraging the MCP SDK on the client side will generally give you recommendations of how many is safe to run in their environment, okay? And so what we've got here is a couple of ways of linking these clients to these servers. The first one is we can link these clients to servers that run on my same machine or that run in the same cloud instance or run inside of a Kubernetes or cluster or whatever. And those local data sources, for example, or local APIs may run locally to my system. So this is a great way when you're writing code, you're building your own MCP servers or your own client implementations based upon the SDK. This is a great way to kind of get this started. But ultimately, in a production environment, you're generally going to have your applications talking to remote MCP servers that are generally hosted behind an API gateway or behind a load balancer or in a Kubernetes cluster, or they're running as a function, but they're generally running nailed up as a highly scalable service. And they are, again, the intermediary between whatever it is you're doing on the AI side to whatever it is AI needs access to. So when we look at this from a communication protocol, MCP clients exchange messages to servers over a well-known standard, JSON RPC 2.0. And oh, by the way, if you get into agent-to-agent stuff, so the A2A project that Google donated to the Linux Foundation uses the exact same wire format. So everybody's pretty much finding that JSON RPC as a messaging mechanism is very, very efficient at pushing back and forth context in an AI environment. So this is kind of the standard way that we do this. And so there's two ways that clients can communicate with servers. The first one is locally over good old-fashioned STDIO. Yes, you heard that right. The good old-fashioned STDIO that has been with us since the dawn of computing. we can actually dump JSON RPC context from a large language model or to a large language model over a regular STD in, STD out. And that means that the MCP server needs to be running local to have a connection to the, I'm air quoting the bus, but the STDIO kind of environment. And so this is a great way, again, if you are writing client code, talking to client servers, and you want to talk to your own local file system on your machine, or you want to talk to SQLite on your machine, this is a great way to make sure that the actual protocol and all of your code is actually working effectively. But where you're going to go is the next thing you want to do is once you download an MCP server or you build your own MCP server, you want to test this out. And so without writing a bunch of SDK code on your own, the best way to do is to go to the Model Context Protocol main GitHub repo and download the inspector. It's very, very simple to get. And the inspector is a client, and it allows you to point to any server locally on your machine or via a URL path to a remote destination. And so what you would do here, for example, if you wanted to actually aim at a local file system in your environment, you would run npx, this is a Node, a Node.js based implementation. So you'd say, I'm going to run the inspector, and then I'm going to run the MCP server, which is called file system. And the only thing that the MCP server has access to is this path on my local machine. Okay. And as soon as that fires up, you'll actually see the proxy running. Again, MCP servers are proxies. And you can actually see the transport type. So it's STDIO, which means that everything that comes out of the client will talk to and from the server over this local STDIO connection, okay? And we'll see an HTTP version of this as well. And so what's really groovy about this, if you're a Wireshark nerd like I am, is get this running, fire up a Wireshark, and aim it at port 3000, take a look at 5173, and then whatever other URLs you have for other MCP servers that are running, port 8080 or whatever it is. But they're all going to be an STDIO. They're all going to be running local to your machine. So you'll be able to pick them right up off the wire over your local host, okay? And so you'll actually see in Wireshark all the JSON RPC messages flowing to and from. Now, the other way of getting this done, and this is really going to be the predominant way that you would implement this in a production, is that you're either going to see legacy HTTP SSE or server streaming events or server sent events, which has been around for a long time, way before any of the AI stuff came around. And if you see HTTP SSE on the wire, that means generally one thing, that the implementation of the client and or the server was written before March of this year. So prior to that, the MCP spec said whenever you open an HTTP post between a client to the server can open up an SSE, which means it's a streaming connection that is a long-lived flow. We do this within the AI world because the LLMs may take a while to get all the context sorted out to send it to the server. And then on the backside of the server, it may take the server a few API calls to get all of the information that the actual context is asking for it. And so what we don't want to be doing is opening, closing these connections all the time. So SSE is kind of the mechanism for long-lived flows back from the server. Now, what the MCP community found out is that they needed to make some extensions to the way SSE operated specifically for AI. And so they came up with a brand new implementation called streamable HTTP, and it's almost damn near impossible to actually look on the wire and see the difference, other than you'll actually see when the clients and the servers connect to one another, you'll actually see that it says streamable HTTP. But on the wire, they pretty much operate the exact same way. And so what happens here is if you've got a brand new client that is talking to a older server, the client may open up the connection with streamable, but the server doesn't understand streamable because it was built prior to the SDK change. And so they both have to fall back to the last known good implementation, which is SSE, okay, on the wire. And so this is kind of how it flows. So let's take a look at a connection. So I'm a client, I'm Cursor, I'm VS Code, whatever it is. I will send an HTTP post to the URL or the IP address. Again, it can be local, it can be remote, to the server connection. And I'm going to do a method of a tool list. Give me all of the tools that you have as an MCP server, you're a GitHub server, whatever it is. It'll give me a list of all those servers or those tools. It could be one, it could be 100. And then the context will change. Now I actually want you to give me this one bit of information out of this tool. In this example, the MCP server is a forecast application for weather. So there's a URL that is a non-AI enabled weather app. It could be Weather Channel, whatever it is that you're connecting to. And now the context changes from give me a list of stuff to now I know exactly what I want. I'm going to do a tool call called get forecast. And there's a required argument that the server sends back in its capabilities exchange that says, give me the latitude and longitude that you want. So that's the post to the server. Once the server knows what exactly the context is and it matches its definition of the tool call, it will send event. That's the SSE or the streamable mechanism that gets turned on here. And so you'll see an event message. I speak JSON RPC 2.0. My result is blah. And here's the information back to you, okay? And so this is a typical exchange that you'll see between clients and servers by the gazillions, right? Depending on what the tool call looks like. Now, from a use case point of view, you very often will aim MCP at things that you hate doing. So if you hate writing reports across lots and lots of different data sources, MCP is awesome because I can go into my interface and do a natural language query. And if the large language model has not been trained on it, it knows I need additional information. So it may go to RAG, if RAG is an architecture in your system, or it may go in and do a tool call. And so it may do real-time information. Like I will say, give me a report of all of the hosts that Ansible is implemented in a Cisco API through iOS XE or through NetConf or whatever the thing of it is. And at the same time that you produce this report, write that report to a GitHub repo, right? And so I, in one single blob of context, have asked for a multitude of things that you would normally have to stitch together by hand. And so what this does is this gives us, lots of access to doing a lot of automated routine tasks that either we don't know how to do because we're not Jenkins experts or we're not, NetConf experts to reach into an SD-WAN environment, whatever the case might be. What that does is that allows us to democratize all of the complex data in these systems hold so that it gives us way, way better decision-making around, what actions do I need to take on this data? Now, the thing that is always the icky part of this is that the compliance and security is not always nailed down. There is no defined standard that says an MCP protocol must support zero trust. It must have encrypted capabilities exchange. All of these different things are up to the implementation interpreter of the server. So this is very important for you to figure out, is that you just don't go randomly download some MCP server off the internet, drop in your production tokens into that exchange, and then start asking cool questions, and then just, the entire world melts down on you, right? You want to go with, kind of trusted MCP servers, typically the ones that the vendors are putting out, GitHub, Argo CD, Jenkins, Netbox Labs. All of these MCP servers are built to kind of understand the security parameters that they're operating in. So let's take a quick look through a typical kind of workflow that you would start with from an MCP point of view. So you may be an operator, or you may be a developer, or you may be, an admin that is using some sort of an IE or an AI-enabled IDE. It could be VS Code with GitHub Copilot enacted. It could be Claude Code. It could be just good old-fashioned Chat GPT that you're using. And you configure the MCP server that you want to talk to, again, locally or remotely. In this particular case, we're actually going to interact with Cursor to interact with a GitHub MCP server and an Argo CD server, which is a continuous deployment server. And we're going to interact with that to get some things moving for us inside of our operations. Now, someone else may want to interoperate with these systems that have no idea what an IDE is, okay? So now you can have other types of things like an agent that is inside of your enterprise, like an Argo CD agent or a Kubernetes agent that can come and interact with this through natural language and not have to know anything about an IDE. So we're going to walk through that. And basically what we're going to end up with at the end is that, just for the sake of time, I ask Cursor to create a new GitHub repo in my org and upload some files that we're going to use to build our pipeline out through AI. And that pipeline is going to light up an Argo application from a file. That Argo application is going to go through and create a Kubernetes job that loads an Ansible runner that uses these config files for our changes into a Cisco DevNet sandbox and make a loopback config change for us. Okay, so normally we would touch a lot of stuff by hand to get some of this stuff done, and we're really going to nail it down pretty quickly here. Okay, so hopefully you can see this in the back. So what I did ahead of time is I simply went into Cursor with a directory of 3 files, and I said, or 3 directories with files in them, and I simply said, create a new GitHub repo. It already had the MCP server configured for my credentials to GitHub, and I want you to upload, do a push of these 3 folders, and then I want you to look at the folders and create me a README. So I never gave it a README. So AI read all of the files and figured out what the files were for. An Ansible playbook, what the loopback config was for. It even knows down here, one of them is a loopback interface for IPFIX. So it generated the README on my behalf. So imagine what this kind of can help you in your day job, okay? So the next thing that we're going to have the system do is that when I ask AI to create a new Argo application, it's going to know that there is an Argo CD, and that's probably tough to see in the background. It's going to go through and it's going to comb through these files. It's going to land on an Argo CD application definition, and it's going to say, cool, I'm going to create a brand new Argo CD application that watches this repo we're in, and any changes that get triggered from a commit in there, I'm going to build the Argo CD application, and that application is going to create a Kubernetes job in the cluster. It's going to load this image, and it's going to run this Ansible playbook, which is loaded in the image, and it's going to call these 2 files that exist inside the repo. And inside of that Ansible config will be the never do this static credentials for our sandbox, right? Don't do this in real life. And we're going to make this loopback config change inside the environment, okay? So what we're going to do is we're going to interact with this system here. And you can see that I already, in this definition, I already told it to create the README. So we're going to actually go through here. And what I'm going to do is I'm going to simply say, create an Argo application from the information that's at that repo. That's all I'm going to do in here. And so we're going to kick this off. And hopefully the demo gods are with me. My VPN connection between here and San Jose's environment has been a little bit dodgy. So what it's going to do is going to say, hey, cool, I'm going to let you do this. Let me start working through this. It's planning what it's doing. I've got it in auto run. Please don't do this. And it's going to go out and start planning my moves and start doing what it needs to do against this MCP server that we've defined here, which is running localhost with this particular hash, okay? So if we come over and look at it, it's going to start working on this, and you'll actually see this application again, if my VPN holds up, there it goes. So it's already created an application. It's already creating a job. We go look at the logs. It already knows that it's making a VPN connection over a netconf connection into an iOS XE router inside of our sandbox. So we'll watch this. This is the one that usually fails on me over the VPN connection because it's timing out trying to pull the Ansible image. So we'll see. There it goes. So it already hit. So I simply said, look at that repo and play out what's in the repo that I committed from an operations point of view. And so if we go over to the SD-WAN environment, may have to do a refresh here. Come on. I've got it zoomed in big time here, so it's not showing up very good. Show IP. My God. My God. So we can see the loopbacks in there. And we can see the config. Okay, so we've now interacted with that. So now the other thing that we want to look at is, okay, this was your job. Right, you're in your IDE, you're the one that's creating Ansible playbooks, you're the one that's interacting with the cloud native environment, whatever it is that you're doing as an operations point of view, you have created this and allowed AI under certain conditions to automate this workflow that you were touching by hand. But what if I'm not? What if I'm Adrian? He's clueless with IDEs, right? I mean, just look at him.
You know, that's a joke because if any of you were at his CI/CD pipeline discussion earlier this week, you'll know that he is not clueless. But maybe that's not his job. Maybe his job is they're an observability or an SRE or a platform engineer that needs to make sure that when a trouble ticket comes, like a long delay or timeouts of pulling images out of the enterprise, image container or image repo, that I got to go and figure that out. And what I'm not going to do is go and try to beg for permissions across all of these platforms to just get read-only access to it. And so this is where things like agents, purpose-built to do a one-to-one relationship with an MCP server can help you. And so a great project for you to run, all of this is running on my machine, except for that iOS XE router is running in San Jose in a DevNet sandbox. But everything else that we're looking at right now is running on this machine. And so there's a project called kagent.dev. I'll drop the URLs to this into the space later on. And it ships with a lot of operator-centric agents. So if you're running Cilium in your cluster, if you're running Helm, you're running Kubernetes, obviously, you've got all of these pre-built agents. So I wrote 2 agents in here. One of them is an Argo CD agent that we're going to interact with. But if we go and take a look at what one of these agents would look like, they're pretty simple. So I'm going to go back to my agents here. And what I've got is an agent here that's got its name. It's a declarative agent, which means I'm declaring it as a brand new agent native in the system. I'm not importing it from Langsmith or A2A or some other framework. And then I've got a bunch of agent instructions that are very specific to Argo CD, right? And so there's all kinds of best practices and templates for you to use here. And so you would bring this in, and then the next thing you would do is you would select the model that your agent would use. And then the final part, which is really the topic we're into today, is linking the agent to a singular or multiple MCP tools. Okay, in this case, we're utilizing the commercial Argo CD tool, and you can see all the tools that this agent now has, right? And so you can basically start to build this environment in here. And so now I can say, you know, give me the health of the Argo CD application. And so now I can start to ask normal chatty style kind of interface type stuff into this environment. And so now I'm interacting with a continuous deployment system that I generally don't know anything about. So I can go and say, okay, do you have open telemetry enabled? Yes, show me the traces for this connection from a server to a client, right? And so you can begin to interact with this from any type of interface. And this is why the MCP SDK is so important, is because you can give per user tokens or per role tokens in MCP to a person to give them read-only access from a completely different interface than the one that you live in, okay? And so this, again, is the importance of having these as standards. So if we kind of come back here, we're about at our time. This is not enough for you to go and just start launching into MCP in your production, right? So I'm going to give you some links to go do some additional research. So I've got 3 YouTube videos on the Cisco DevNet channel that will give you a much deeper dive on the architecture and the components. We'll go into a lot more on use cases. And then I've got lots more other demos. So for example, I've got a demo that people really like because they're big NetBox Labs fans. And so we're using the NetBox Labs MCP server, the GitHub MCP server, the Argo MCP server, and we're basically utilizing through natural language a way for us to extract information out of our NetBox database and get it into Ansible playbooks and get that into our runtime, all through natural language, right? And so can imagine if you're new into an organization, you don't really understand their playbooks, you don't understand where all of the tenants are for NetBox and all this other good stuff, being able to actually have this as an onboarding mechanism would be quite something, right? So here's a bunch of resources that are used in here. Inside of my instructions inside the YouTube videos, I point you to some links for you to reproduce this exact same setup that I've got in here. And again, you can run this on any machine that can run a container, okay? And so this is some reference stuff. So MCP is off to a strong start. We've got a multitude of talks that have been going on this week. There's more of them to come. And it is really, really well tuned for those of us that run ops or admin stuff to lots of diverse tool sets. Okay. So it's very good, but it's also young, right? I mean, we were humming along writing SDK code for clients and servers. Then all of a sudden the organization comes up and says, you know what? HTTP SSE is not really scaling well. So we're going to go to streamable HTTP, which is a brand new protocol, right? And so you kind of have to expect some of these changes from underneath you on some of these elements. MCP, again, is ideal for linking large language models, which could be agents. They could not be agents. They're just a good old-fashioned LLM that you need to go and have a chat interface with. It doesn't need to be an autonomous agent or something, but you want to be able to link them to a multitude of things that have no idea what AI is. Your GitHub repos, your Redshift databases, whatever it is, they're just tools you already have in your environment, but you need to give some conditional access to these LLMs to that information. The MCP SDK is a way for us to kind of standardize how we get that done. It's equally important to understand what MCP is not. It is not an agent-to-agent framework. That's what A2A is. So go and take a look at A2A, which Google donated to Linux Foundation, and it is what MCP is to tools. A2A is for agents to agents. Let's establish a standard means by which we exchange information between myself as an agent and Adrian as an agent. Let's work together to solve this task that someone gave us, right? And MCP is only part for the tool. So because on behalf of data sources and LLMs, that means it's not one, right? It is not there to replace your APIs. It is not there to make your Kafka bus operate better. That's not its function. But I'll tell you in closing here, what MCP will do very rapidly for you is reveal how terrible your APIs are. So if you've got bad APIs or you have a vendor that has bad APIs, the LLM, which is a pleasing function, will invent new things that your API has never done nor will it ever do. And now you're chasing debugging issues because it's looking at verbs at an endpoint or a path that have never existed, right? And so your documentation around your APIs and those types of things, the better the quality of those are, the better exchange you're going to get out of MCP, okay? So with that, thanks for the quick 30 minutes with me. I hope you you got something out of it. I'm here for the rest of the week, so trip me in the hallway if you want to, and we'll chat about MCP. Thanks. Have a good day.
All right. Can everybody hear me? If you've got your headphones on, have I entered your personal sonic bubbles? Wonderful. Excellent. All right. Well, welcome back to the Cisco U Theater here on day, I don't know, what is it, day 12 of Cisco Live? It certainly feels like that. It's Wednesday, right? Yeah, Wednesday. Whew. Time zone changes. My name is Hank Preston. I'm a distinguished architect here in Learn with Cisco, and I'm going to talk to you probably about the first time this week that you've heard about this new topic that's out there called artificial intelligence. Have you heard about this thing? Right? It's starting to grow. I don't know if it's going to become anything for real, but we had an extra slot here at Cisco Live, so I figured I'd talk a little bit about it. All jokes aside, man, AI is amazing. Can you believe we've hit the 3-year anniversary from when ChatGPT 3.5 first launched and went live? It's only been 3 years. 3 years, and 90% of Cisco Live is about artificial intelligence. Really, because amazing. Now, most artificial intelligence that we talk about revolves around cloud-based public or private/public AI solutions that run in these giant nuclear-powered data centers, soon to be in space. Today's session is going to be a little bit different. We're going to talk about how we can actually run generative AI locally right on a laptop like the one I have here. Because we don't need those giant public cloud data center models. And sometimes we don't want those. And there's several tools you can do for this, but the one that I'm going to talk about today is called LM Studio, which allows us to have phenomenal AI power without the cloud. My session today is going to go through a few steps. We're going to start out with why should we consider local LLMs? The cloud LLMs are awesome, right? They can generate pictures, they can tell haikus, they can pretend they're pirates. why would we even bother thinking about a local LLM instead? And then, exactly what is LM Studio? We'll talk about the basics of it and why I think it's a valuable tool that all of us should be comfortable using. We'll then talk about how do we find and choose models, because that's something that's important to recognize. As soon as you go local LLM, you have to decide which one of the models to use. Boy, are there a lot of options. So we'll go through some of the aspects and how to evaluate and pick a model that might be appropriate for your use case. And then last, we'll go through as many demos as I have time for before my time is up today. So that's our journey. So why should we consider local LLMs? There are a handful of reasons. The first one is this. If you're like me, you take advantage of the public cloud LLMs, but I don't have unlimited pockets. I can't sign up for subscriptions with every single service that's out there. And so I'll be deep in the middle of this amazing work that I'm doing, transforming the future of network engineering. And then all of a sudden Claude pops up and says, oh, you want to keep chatting? Like sign up for a subscription or come back at 8 p.m. This as a service brings limitations that sometimes can be troublesome. And I'm not saying like don't sign up for a public cloud subscription, but they can be challenging. They're expensive, right? Even $20 or $50 a month can add up a little bit depending on the use cases. So this is one reason to consider, can I leverage an LLM on my laptop? Okay. The next one is another hopefully obvious one, security and privacy. We want to keep our prompts and the responses to ourselves. Those public cloud services, even if you're paying for the subscription, generally, as soon as you sent them a prompt, you have released ownership of that question that you said. The response that generated, you don't have ownership of that either. All of that is maintained as part of the cloud service, and in the future could show up inside of future trained models. That's how they're iterating, making the next versions of those. So there is a reason to try to want to keep stuff to ourselves, not send all of our information to big AI in the cloud. Right? Maybe you're working on that next really innovative idea. If you're using a public cloud service, right? You've now told everybody in the world about it. Right? So the privacy and security is a real one to keep in mind and consider. Next up is this. We're in the very early stages of AI, right? Each and every one of us, I imagine, is still learning how to correctly use AI. What's a good question? What's a bad question? And during this learning phase in our experimentation, we don't always need a nuclear energy powered data center simply to do a hello world. This is an actual screenshot from my LM Studio instance. And you can see how many chats I had that were just terrible. I was iterating. I was trying something out. Not all of that needs to consume as a cloud service pieces. And then lastly, occasionally, we don't actually have access to the cloud, right? Sometimes we're offline, we're off the internet. Now, despite the fact when you get in a plane, you actually get closer to the clouds, it's often hard to access those. Wi-Fi on the planes is not super reliable. And true story, I was coming back from a Cisco Live event, flying over the Atlantic Ocean, had to do some work, and I was able, with LM Studio, to work for about 6 hours and use generative AI to work through processes without having to have the cord attached or the Wi-Fi signals functioning. So there's a ton of really good reasons that being comfortable and having an option for local LLM use should be part of your tool set. It won't replace the public cloud services because I don't always need a nuclear powered data center to power my LLM, but occasionally I do need the nuclear powered data center to power my AI requests. And so it should be part of our tools that we're after. There's several options. We're going to talk about LM Studio today. So what exactly is LM Studio? LM Studio is a desktop application designed to make the barrier of entry for local LLM usage as low as possible. And they have done a phenomenal job with this. It's a local application that will run on your laptop or desktop computer. And it gives us this nice, easy to use interface where we can kind of navigate our chats. We can experiment with all the knobs and settings and things that we don't often have access to if you're using one of the public cloud services. You can peek under the covers to understand what does it mean to tweak the temperature of my LLM engagement, right? If I adjust my context window, what does that do? And so it gives you access through this interface to go after it. If you're working on building MCP servers for different pieces that are there, you can use LM Studio as your MCP client to design and develop and use as part of your workflow. You can build yourself little micro agents. The simplest of agents is an LLM and then some sort of a system prompt. So I've got an example here. You're an AI assistant that specializes in network operations support, all running on my laptop. So it gives you all of these different use cases that you can dive into. And LLM even offers APIs and SDKs so you can leverage it and then write your own conversational agents or experiment with the APIs, build code that is AI powered. All of that can be done with LM Studio. Now, it's a desktop application that does have requirements, right? You have to have an appropriate machine that it can run on. It is supported on Mac, Windows, and Linux. In the Mac world, you need to have Apple Silicon. Most folks these days are at Apple Silicon, but there are some Intel Macs still out there. Right now, they do not support Intel CPUs for their Mac operating system. It's got to be either an M1 to M4. The faster it is, right, the better GPU you have, the more capable LLMs you'll be able to run. But even with first generation M1s, you can run and experiment with the local LLMs. In the Windows world, it supports both x64 and ARM-based processors, so you can kind of bridge both of those worlds. It recommends a decent amount of RAM. The more RAM you have, again, the more intense the more powerful LLMs you can leverage, the larger queries you can do. And you're going to want a GPU with at least 4 gigabytes of dedicated video RAM. And then on the Linux side, right now, they support only Ubuntu 20.04 newer. And then you're going to want a 64-bit CPU, and it's distributed out as an app image. Now, I've actually talked with some of the folks over at LM Studio asking about how they decide when to go through different Linux platforms. Will they ever support Intel-based silicon for Apple? And they're running like any of the small companies. As they get interest from customers and use cases, they expand their footprint. And so if you're not an Ubuntu user, you're a CentOS user, Fedora, right? I imagine we'll see more and more of these start to come in. Now, what's interesting to me is that for years and years, right, we kind of plateaued with what our desktop requirements were from a hardware perspective, right? For the types of things we were doing, even if you're doing automation and coding, right, there's just only so much CPU and RAM you need to be functional. AI is an interesting beast. When we start to move to local and edge size use cases, which I think we'll see in the future, more applications doing that. Now we're actually going to need real RAM increases and GPU increases. And so this is going to be an interesting change in what the footprint for the average performance knowledge worker's laptop is going to be. Is we're going to start to see requirements like this show up. Now, LM Studio is created by Element Labs. They're a small New York City-based company. And they're focused on trying to make AI easy to use for the average person, okay? It was founded by a former Apple engineer, and they make their application, LM Studio, free for both personal and work, which is encouraging to me. When it first came out, it was free for personal, but if you wanted to use it at work, you had to call them and work on negotiations and pricing, and then they realized that was causing them issues, and so now it's free to use for work as well. It's not an open source application, but under the hood, it is making use of open source components. It does not come with the LLM itself. So it does not ship with an LLM model, but it makes it very easy to download them from the open source or the like the GitHub of open models called Hugging Face. And it gives you an interface to kind of work through those pretty easily. And it provides all of these capabilities to take advantage of it. So this is what it's after. So you download LM Studio, you open it up, and you're ready to send your first chat. You do not have a model to talk to. So how do we find and choose the models? Well, it's an interesting quote that I pulled out here from the Paradox of Choice. When we have too many choices, the very fact that there's a chance to get it wrong makes us feel uncertain. We'll talk about how this factors into the AI space, but am I the only one that's ever sat down with a plan for an evening to watch a movie on Netflix, and then 45 minutes later, I'm still just scrolling, trying to figure out what movie to watch? Right? Too many options. And I grabbed this screenshot today, I updated. We have over 2 million LLMs available for download on Hugging Face. Right? Over 2 million. 2,242,490. You know how long you could scroll through that trying to figure out which one was the perfect model for you to use? I'll give you some tips on how to avoid that. The first one is don't actually just go to Hugging Face if you're just getting started, because you will quickly get overwhelmed. There's too many choices. And so what we get with LM Studio is this kind of integrated model search that plugs back into the Hugging Face interface and allows you to kind of more easily factor in and find the models that might be good for you. The easiest thing to do when you start is to stick with what they refer to as their staff picks. Right? That's the default search comes up with. The staff picks. These are the models that the folks at Element Labs behind LM Studio have looked at these models and said, okay, they are safe-ish, right? They're not going to sign a legal document for you, but they've looked at them, make sure that they do what they're supposed to do. They work functionally. They've been tagged with what their abilities are. They've got documentation to say what's after there. So start and stick with the staff picks that are out there. And then you can go into each one of the model cards and kind of start to read through what is this model about, so you can decide if this is a good one for you, because you're going to be choosing which one of these to download and run on your laptop. The first thing to know is what is the model and who made it. So up at the top in red, we've got OpenAI GPT OSS 20 billion. So this model was created by the folks over at OpenAI, and it's called the GPT OSS model. It was released a few months ago. Now, capabilities is an interesting thing. Not every LLM is capable of doing the same aspects. And so they're tagged inside of LM Studio. This model is good for tool use, MCP servers, and it is also a reasoning model. Reasoning means that when you make a prompt into it, it doesn't just immediately start streaming out an answer. It does some thinking about your prompts to decide kind of a strategy to go after. You want to know the format to some extent, right? So we've got both GGUF and MLX. GGUF is a cross-platform way to run models. It's going to use llama-based libraries to go after it. The MLX indicates that there is a version of this model that's specifically been designed to operate well on Apple Silicon. Right? If you're an Apple user like I am, these are nice to see. They run a little bit better on my laptop. You can see how many parameters. The parameters is a little weird, but it generally tells you the complexity of the model, how big the neural network is, and generally more is better. But that doesn't mean that the bigger the model, it's always the better choice, right? Sometimes you want to weigh them. Smaller models sometimes work better. The architecture, so what's the family that this model is part of? This one is part of the GPT OSS family. It's not a very big family yet, but that's the family this particular model comes from. And then lastly, you want to understand the model size. How big is it? So this model is 12.11 gigabytes, and LM Studio tells me, hey, with your hardware, you can get full GPU offload possible. That means I'll be able to take this model and fully run it in hardware on my laptop to get the best performance possible. It'll give you warnings if you pick a model that may be too big for your laptop. And so it helps you understand. I can't run the largest models on my laptop, as nice as it is. So you can kind of pick and choose which models make the most sense. Now, there are a ton of models and a ton of families out there. So I put this little cheat sheet together that I think is useful to see. Because most of the models that you'll find will fall into one of the architecture families listed here. GPT OSS, Gemma, Phi, Granite, Mistral, Llama, Qwen, and DeepSeek. Okay? And so where do they all come from? Each one of these architectures originated with some AI company. So OpenAI had GPT OSS. Gemma comes from Google. Phi comes from Microsoft. IBM has their Granite models. Mistral, another small startup AI company, has their Mistral family. The good folks at Meta give us Llama, and then Alibaba gives us Qwen, and DeepSeek gives us DeepSeek. Okay? This is important to understand because if you're like at least Cisco, our IT company our IT and security folks have gone through and evaluated and done security checks on different architectures and models, and said which ones we should be considered fully safe, which ones we need to be more cautious about. So knowing where these things come from is important. And now the main focus and strengths in here, I didn't come up with these. That's not my advice. That's what the model providers themselves say they're good at. So I just kind of took their word for it and put it in the chart. I think this is useful to see. And you want to experiment it kind of across the board because you'll see different capabilities on all of them. A few suggestions when you're picking your models, right? Avoid community models from sources you don't know. So by default, LM Studio focuses on their staff picks, but it will let you go in and look at the 2 million plus models that are available up on Hugging Face. Until you get really good, you know how to evaluate them, you know how to make sure that they're what you're after. Avoid the community models because you don't know what fine-tuning was done. Once a model is created and released, there's no way to peek under the covers and see kind of What was it trained to believe? So just be careful when you dive into those. And test different models. Bigger models are not always better. And a model that's really good at one use case may be terrible at another use case. So this is something that's valuable when you dive into this, is to experiment with what you're after. And open models does not exactly equal open source. The details of the difference of that is beyond what I want to go into today. But if you're going to use one of these models for anything more than just experimentation, be sure to look at the actual license for the model that tells you what you're allowed to do with it, whether you have to have any knowledge on that side. So that's the kind of the layout, the information that's available. What types of things can I do with LM Studio on my laptop? I have a whole bunch of demos. I will not be able to get through them all, but they kind of span across a bunch of different things that are possible with LM Studio. Some basic AI-based chat features. You can chat with a model. You can tune the parameters. You can understand what's in there. In a network space, you can do configuration analysis. You can experiment with RAG with LM Studio right locally on your laptop. And then from Agentic AI, you can actually use it to design and test MCP servers or learn how to experiment with building conversational AI systems. So vast, kind of huge possibilities of what you can do with LM Studio. So first demonstration here, we're going to start super simple, just basic conversation and the ability to tweak and experiment and understand what the different parameters to tune a model is. So here in LM Studio, I can go in. And take a look at all the models that I've downloaded. And I have a whole series of models I've downloaded to my laptop. And then I can go and pick which one I want to use. I'll pick GPT OSS here. It loads it up into my hardware, and now I can start to experiment with it. GPT OSS is a reasoning model, so I have the ability to tweak how much do I want it to think about the question. Low, medium, or high. So we'll start out with low and say, I'm going to use low reasoning, and I would like it to generate a well-thought-out joke about network engineering. It should be technical, avoid anything too terribly spicy, and tell me what's there. And so we can see it thought for 0.00 seconds, and its thought was, hey, I just need a joke with CCNA knowledge. Let's create a joke. So super quick, came up with a joke. Why did the network engineer break up with his router? Because every time he tried to connect, they just keep spoofing the relationship, never got real. It's okay, not the greatest of jokes. Kind of see what's possible. But now, I thought to myself, this was with low thinking. What if I raise that level up and I say, I want high thinking, right? Really put your effort in to create the best networking joke possible. So I change it up and I say, how about another joke? It starts thinking, all right, I want a joke about networking. I've already given this joke. What could we make the joke about? Maybe spanning tree, maybe routing. And we'll let this go for a little while as you kind of see it think. What I found was it never stopped thinking, right? I tuned it too high, but it never got convinced. Some of the jokes that it flies by are like, those are not bad, but they were never good enough, right? It was overthinking, which is an example of the tuning of the parameters. More is not always better. You don't always want the highest level of thinking. You don't just get stuck in a loop with just creating a joke. And it will just go on for, eventually I end it and stopped because I got bored with recording the screen. But it gives you the ability to experiment with these things. Next demonstration, we can use LM Studio to create a basic assistant, or these days we call them agents, right? So what a system prompt is it's a way to go in and tune and tell the model, right, what I want the model to do. So I'm going to pick this prompt here that I created, the network engineering agent. We'll open it up and it says, okay, you're an AI assistant specialized in network operations. Your primary goal is to assist with these types of tasks. Always prioritize clear, accurate, actionable guidance. So I can start to build my own agents that I'll run on my laptop. With the agent personality created, now I can start to take advantage of it for things that are actually real that I might do in my job, where the privacy and security of a local LLM is important. So as an example, I've been asked to come and help a customer of mine look at their spanning tree configuration. The network is composed primarily of Cisco Catalyst switches. They recently had an outage. I want to get ready. I want to be on board. Can you help me plan for this meeting? So I fire this off into it. It starts to think through it, gives me a little bit of thought process here, tries to do some planning in advance, and then it starts to build. Well, here in a second, it'll build the response that says, okay, you're heading after this. Here are some things to look for. what commands to capture, and it creates a list of commands that I can go after. It can even formulate an email that I might send off to my customer in advance of my meeting to say, hey, we're coming out, we're going to talk about spanning tree. Can you make sure you have all this data for me ready to go? Running this locally, because it's on my laptop, I don't have to worry as much, right? I still say we should all be a little bit worried. So I'm like, think about what you're doing, but you don't have to worry as much about asking questions that may touch on things that are intellectual property or confidential conversations, because again, on my laptop, that's where this is at. Lots more use cases we can dive into. We can talk about the ability to do network configuration analysis. I'm a little cautious in my use of AI for different use cases. Some people want to jump in there and just be like, hey, AI, create me a network configuration. I figure I'm pretty good at creating network configurations, but even the best of us want to have a second set of eyes. So I love this use case here. I put this template together for deploying IPFIX using iOS XE routers. Can you check and confirm it looks okay? Nice use case for it. However, I'm using the GPT OSS model. Am I confident that it has a good set of knowledge, right? That it's got just good details in there. We've all heard of hallucinations before, the fact that AI models will occasionally just make crap up. Right? So we can use LM Studio to try to get around some of that by taking advantage of the ability to upload source documentation as part of our queries. So here I go through and say, okay, I'm going to upload all of the Cisco iOS XE IPsec VPN configuration guides. I'm going to upload those and attach them into the conversation. This is where RAG, Retrieval Augmented Generation, comes in. Now, the response will be generated based on content that comes out of these guides. So when I send off my prompt, same prompt, but now it's going to go ahead and use those documentation to find the answer. My confidence level goes much higher, and I can, again, do this right on my laptop. We can see it went ahead and figured out how to use the content. It retrieved 10 relevant citations, and now it's processing through the citations, coming up with the answer, and that gives me a sanity check. And sure enough, it did find that I had a typo in the configuration. Somewhere in here it points it out. Right, so it gives me the ability to do these kind of configuration analysis, leveraging good known documentation. And if I let it go farther, it'll even point out the citations that we use. So where did it find the documentation? So it'll even point you back at the snippets of things from those documents. Really useful feature set. Another aspect, we don't have to just do text-based analysis with LM Studio. We can use LM Studio with a model that has vision capabilities. That's what this little yellow eyeball means. It means that this model has the ability for it to actually look at a picture, a JPEG, a PNG, and consume and process that. So I load up a vision-capable model like that one there, and then I take a network diagram or a snippet of a network diagram, and I attach it, where is it? I attach it into the chat, and then I ask, can you describe this image for me? This image depicts a small network, runs through, provides details. We'll go ahead and pull out content information. Here are the VLANs, here are the IP ranges. Like really useful capability when we bring vision in. Now, I will say, vision processing from an LLM is very intensive. And so if you're doing this locally, you'll likely have to snip your images down. If it's a really big, complex image, the hallucinations just get wild, right? But if you take small portions of your images and put them into something like LM Studio on a laptop, you can get really good information out of it. So we got some more details here. I think it's almost done. So we'll see that it comes through and it gives me the name, the VLANs, the subnets that get pulled right off the documentation that was in there. And then gives me the CSV file. And if I go in, we can see there's the IP address. And just to show that it did it right, it goes back in, and sure enough, that was the actual IP address. I point that out because this is something that I've actually seen ChatGPT and Mistral and some of the big cloud models be very, very bad at. It's like they usually just make IP addresses up, but it actually got this one right. So coming down here to the end, another example, MCP server development and testing. So the session before this was about MCP servers, so I wanted to create some of my own. So I generated an MCP server that uses PyATS to send show commands, and then I downloaded the NetBox MCP server from the good folks at NetBox Labs, and I ran those right on my laptop, and I attached them into my LM Studio. And now I have the ability to go ahead and say, I want to work on router 01. What is its out-of-band management IP address and SSH port? And so it goes ahead, uses the tools from Netbox to retrieve data. It'll figure out what is the information that I asked for. I can then combine that together with requests from using the PyATS tool to pull information out of this device, and again, all running locally on my laptop. I'm experimenting, and I imagine all of you should be learning how these MCP servers will fit into your future agentic AI operations. This is a way to check them out and see how well they work in a way that doesn't require you to use a public cloud service. Right? Claude Desktop is a great tool to use for MCP server testing, but generally that you're going to be sending all that stuff off to the cloud. This again keeps everything local as it goes in. We can also do AI development in Python with LM Studio by turning on the API reachable settings inside of the developer pane of LM Studio. Once I've turned this on, I get access to use OpenAI compatible APIs, which are kind of the de facto standard, or the native LM Studio APIs and SDKs to build and develop conversational agents and learn how these things work. And so I created the world's worst example of an AI conversational chat. It's really terrible, but I just wanted to show how you can do this easily. So from OpenAI, import OpenAI, create a client, localhost, that's my LM Studio, and say, okay, here's a basic completion request. Always answer like a pirate. Why should network engineers be excited about AI? Like the super simplest example, fire this off and it just spits out the answer. You can read through it, right? It's not too bad. It does have the Buccaneers, the pirates that are in there. But again, if I'm just getting started learning how to build AI and LLMs into my applications, this gives me the ability to do it locally on my laptop. I don't need to have a subscription to a service. I don't have to worry, again, as much about the security implications on this side because I'm limiting everything right to my laptop. All right, in closing, I collected a handful of links that you can dive deeper into. I've been told at some point these slides will show up inside of the Cisco Events app underneath the slide session files. They keep telling me, so keep an eye. If they don't show up, my contact information will come up in just a minute, and then you can email me and I'll just send you the slides, right? I'm having faith that the Cisco Live folks are going to get those out there for you all. But I've collected, here's the homepage for LM Studio. We have a Cisco U tutorial for free available that will show you and walk you through how to run local LLMs on your laptop for free and with ease. And I've been all sorts of blogging up on blogs.cisco.com about my own journey into agentic AI and LLMs. So I linked to a couple of those. As promised, here's my contact information. I'm generally pretty easy to find, hapresto@cisco.com. And I am learning about AI, just like all of you are and everybody that's here. So if you've got questions, feel free to reach out to me, WebEx or email. Follow me up on the blog site that's there, and we'll kind of figure this stuff out together, just like we figured out so many other transitions, like network automation, programmability, net DevOps. We've been together, right? We're a close-knit family. We can get through this AI thing as well. All right, with that, thank you all. Stick around. We've got lots more content here at the Cisco U Theater today. Bye.
Content that our team would have created as well. I'm focused primarily on the enterprise track, so I'm responsible or attached to big projects like the CCNA, Enterprise Core, Advanced Routing, so NRC, and then obviously all the SD-WAN. So if you're taking any of the SD-WAN content in Cisco U, my hands are all over that, creating the labs and building out the content. And it's a popular thing, so that's why I thought I'd create a session here for the Cisco U Theater. I'm from Ottawa, Canada, so I've come from very far away to talk to you about SD-WAN. More importantly, though, I did bring with me 5 ebook vouchers for the new SD-WAN book from Cisco Press. I would really, really like those books to go to someone who's either getting ready to take the SD-WAN exam, getting ready to push out a big deployment of SD-WAN, and they really need to jump in. I've got 5. So if that's you, if you're thinking of taking the exam or you're working on a big deployment, once I'm done, we'll move over to the side so that the next group can kind of get sorted and settled in, and I'll give those out at that point. All right, so that's what we'll do. So yes, Yes, very, very quickly. Let's go. Yep. Feel free to join the space for the session. I'll upload a PDF of the slides in there as well, so you can always have a look at them there. Very, very straightforward. I'll do that SD-WAN overview. I'll briefly maybe talk a little bit about the training on Cisco U if I've got a bit of time. So there's loads of kind of fundamental level SD-WAN content and more advanced SD-WAN content in Cisco U. So I can talk to you a little bit about that. And then, like I said, we'll do the giveaway off to the side when the session is done. Before we talk about SD-WAN, let's talk about pre-SD-WAN. What did your network look like before? How have we been designing and deploying our WAN networks for the past 10, 15, 20, 30, 40 years? It looked a lot like this. You would have your branch offices, your remote users, all having to connect back through the data center, through the HQ, to get access to all of your servers, maybe that you had hosted there in your data center. More importantly, they would be forced to go through all of your security stack, maybe that was also at that data center, firewalls, inspection, before being able to access the internet. So you had all of this flowing through that center area here, that HQ, that data center. It's not that we didn't have a choice, it's just that all of our stuff, all of our important applications and workloads were hosted here. So they needed to come through here, like the VPN head end was here, to be able to then maybe access the internet. And that was fine for a long, long time. And then suddenly we started doing things like hosting applications in the cloud. And now, getting someone in a branch office, let's say in Perth, to come back to Melbourne to have access to that cloud service isn't the best experience. So we want to change that model. We just want to kind of shift it a little bit. Now, listen, if you're reading a little bit about SD-WAN, maybe some people will tell you it's the end of MPLS finally. That's not the end of MPLS. We can still use, and mostly do still use MPLS in an SD-WAN fabric, but we're going beyond the SD-WAN and beyond the MPLS and leveraging maybe LTE, 5G, regular internet connections as well. We're trying to give you that flexibility of different WAN transports. So all of those different connections, I'm going to call those a transport. So the idea with SD-WAN is to give you that flexibility. I'll keep my MPLS, but I might want to have some other things. I'll give you an example, right? So I'm in Canada, large country like you guys here. If I open a branch office in northern Canada, there won't be MPLS. There won't be fiber. There won't be much of anything except maybe satellite. Maybe if I'm lucky, LTE or 5G. So I need some more flexibility in my WAN deployments when I have that kind of situation. So that was before, and this is now. So as I said, what I'd like to do is allow, in a secure way, all right, I don't want to forget about security, but in a secure way, I want to allow my branch locations and my mobile remote users quickly access to whatever I've got hosted in the cloud. Now, I know there was a huge trend, right? We had everything in our own on-prem data centers. And then a few years ago, we went, oh, this is way too expensive and complicated. I'm going to move everything to the cloud. And then about a year in, you started looking at how much it was costing you to host all that in the cloud, and you had regrets. And you pulled some of that out of the cloud. You brought back some of it into your own data center, and maybe you kept a bit as well in the cloud, which is fine. At the end of the day, I just want to be able to get to all of this as quickly as possible, regardless of where I am, again, in a secure, safe fashion, right? Zero trust, all of that. So I want access to my workloads in the cloud, AWS, Google, whatever. I want access to all of my services that are in the cloud, fair enough, Office 365. And again, maybe I'm hosting my own data center even in the cloud to kind of go with a hybrid thing where I've got maybe some data center on-prem and a little bit in the cloud as well. That's where I want to go. I want to go towards being able to leverage that cloud access from anywhere, but I don't want to forget the security aspect of things. Does that make sense? So just kind of like a before and an after of the whole, I guess, the premise of this. The next thing people ask me, can you give me some idea of some of the features, the components, the advantages of SD-WAN? And before I jump into that, I start by kind of breaking down SD-WAN into fundamentally 4 layers. I'll start at the bottom because that's maybe the easiest one. So as I just finished saying, it doesn't matter where my users are, right? I need that WAN deployment to be available for my branch offices, whoever's on the road, doesn't matter, maybe some colo, cloud services, that's fine, we understand that. And I already talked about this. I want to just be able to do more than have to use MPLS. I'm not knocking MPLS. I'm not saying you're going to get rid of it. I'm going to keep using it. But I'd like to have just a bit more flexibility. I want to be able to leverage those inexpensive, not expensive, inexpensive internet connections for these different locations that might not need a huge SLA, right? So if I'm a small branch office, do I need an MPLS link there? Maybe not. So I want that flexibility. And obviously, 5G. I don't know if you know what this is. Maybe you saw Equinix over here, Megaport. So maybe I want to leverage that as well. So I can connect my fabric through those services as well. So I want that flexibility. Now, obviously, if I do a migration to SD-WAN, I don't want to get rid of my voice traffic. I still want some analytics. Clearly, I need security. Maybe I'm doing SD access that has to integrate as well. So all of the services that I'm currently using, I don't want to throw them out because I've gone to SD-WAN. I still need to be able to carry all of that too. And then finally, this is quite interesting. So when I talk about any deployment, I'll be honest with you, 99% of the time, the SD-WAN deployment will mean that all of the control plane and management plane stuff is going to be in the cloud, typically. But what's interesting with SD-WAN, how many of you have played with CML yet? CML, Cisco Modeling Lab, surely. A few of you. You can build your own little SD-WAN fabric in CML. One of my colleagues, Joe Clark, has a fantastic, maybe 20, 25-minute video on YouTube showing you from A to Z how to build an SD-WAN fabric in CML for free, for you to play around with, right? Very, very easy. So what I mean here by the deployment is that, yes, most of the time we'll have a cloud-based deployment for SD-WAN for all of that management and control plane stuff, but it can also be on-prem. So I'll give you an example. All of the courses that I've developed around SD-WAN, that's in Cisco U, all of those labs are hosted in our data center in Texas. And if you spin up a lab, it's your own little sandbox. And you work on your lab. And you come in and you spin up a lab, you have your own little sandbox. These are all on-prem in our data center. And these are all individual labs where I spin up an entire fabric. It takes about 15, 20 minutes to spin out. And then you get to work on that for however long you need to work on it for, right? So that's what I mean by the different deployment options here. It can be virtual, it can be on-prem. So the features, right? So this is going to be like a little checklist of all the cool things that SD-WAN can do. If someone asks you, what does SD-WAN actually look like? Well, it looks physical and virtual. What I mean by that is, if I go back to my example, I'm in Canada, I open a branch in northern Canada, I send a router out there, a real router, Catalyst 8000 and ISR 1100. My SD-WAN will connect to that router and allow that branch to join my fabric. Right? So it's a real router, right? Real physical device. And there's a bunch of different models. But the other cool thing you can do with SD-WAN is spin up all of this virtually. And I just gave you an example a few seconds ago, and I talked about CML. If I spin it up in CML, clearly it's all virtualized as well. So the router itself can be a physical router, a virtual router. And this is really interesting because remember earlier we were talking about AWS and GCP and all of that stuff. So I can spin up some routers, Catalyst 8000 routers in the cloud, and then connect them back to my fabric to extend my fabric into the cloud. So if I have workloads up there, I can build them into my fabric. Really, really cool stuff. Clearly, I'll have redundancy. So if you work with Cisco to deploy your SD-WAN fabric, they're going to spin up a few instances of redundant control plane and management plane devices so that you don't have any issues with your network. But again, you can do that on-prem as well. I'll give you an example. If you take the course that aligns to the certification, so ENSDW is the exam and the course, all of those labs that I created have two redundant control plane devices, what we used to call the vSmart, and now we just call SD-WAN controller. So I can build in as much redundancy as I want. This is a huge, huge bonus for SD-WAN as well. So again, go back to my example. I've just opened a brand new branch office in northern Canada. I don't really feel like going out there because it's quite cold. What I'm going to do is I'm going to ship my router out there, and someone at the office will get the router, and hopefully by then I have some sort of a WAN connection already provisioned, maybe an internet connection, maybe it's 5G. They're going to pull the router out, power it up, plug it in, and within a few minutes, if all goes well, it will get an IP address from the service provider, DNS information. It will reach out to Cisco, plug and play, to find out who it belongs to. It will then reach out to my fabric if it belongs to me. My fabric will authenticate the router based on the smart account information that it has and join my fabric. And then once it's joined my fabric, this is the kicker, it will pull its config and you're done. So that's what I mean here by the zero touch. Very quick deployment potential for SD-WAN. We go back 15, 20, 25 years, and we looked at a Cisco router. You would have learned at some point in your studies, if you did any CCNA, CCNP stuff, that the router had everything in it, right? It had data plane, which was all of the forwarding stuff, right? It had the control plane, all the intelligence, so to kind of build the routing table, for example, and it had the management plane. So I had to SSH or Telnet or CLI, it was all there. And then SD-WAN, so software-defined WAN, and same thing for SD access. This came about, it's been a while now, right? It's not a new thing from yesterday. We're talking about maybe 10, 15 years now that this is a thing. The concept behind this is I'm going to take that device and I'm going to blow it open. I'm going to pull the data plane out, and that's all the device is going to do. It's going to focus on forwarding packets as quickly as it can. It's going to build my IPsec tunnels if I need them, and it's just going to focus on forwarding. I'm going to take the brains of that router and I'm going to centralize it. That's my control plane. I'm going to have a centralized control plane, and it's going to tell my hundreds or thousands of routers how routing should happen across my fabric. And I'm going to pull out my management plane, allowing me to centralize that as well. So I don't have to telnet and SSH to 1,000 routers to turn on an interface. I want to do that from a GUI, and I want to do it centrally as much as I can. That's, I mean, fundamentally, if there's one takeaway from SD whatever, SD-WAN, SD access, it's this. That's it right there in a nutshell. One of the maybe bizarre, strange, interesting things about SD-WAN is if you build a fabric, let's say in CML, and you turn it all on and you just stand back and you wait a little while, SD-WAN by default is going to build a full mesh topology. I'll give you an example. If you're in CML and you build an environment with 5 branch locations and a data at HQ, it's going to build IPsec tunnels between all of those in a full mesh topology. That's great in a small lab environment, that's fine. But maybe if you have 1,000 branch locations, 10,000 branch locations, you don't want a full mesh. You want something else. Probably hub and spoke or something like that. Really, really easy to do. From the management plane, I log into the management plane. I literally click a few buttons. I go hub and spoke. The management plane talks to the control plane. Okay, you want hub and spoke? I'm going to filter the routes. They're going to talk to me at the hub. The spokes are going to find out how to get to that. That's fine. Going to push that to the router. We're done. We've gone from full mesh to hub and spoke. We talked about this one already, right? I don't want to repeat it again and again, but I think you get the idea. I just want that flexibility for my transports. You guys know about this thing? This has been around for ages. VRFs. Can someone tell me what a VRF means to them? What's a VRF? I mean, maybe you don't know what the acronym is. Maybe you do. So virtual routing, forwarding. Yeah. What was the point? Yeah, just tell me that. What was the point? Did we invent VRFs back a long, long time ago? What were we doing with the router? Segmenting? Yeah. I would take my router and I chop it up into like little smaller routers inside, right? With all its own little routing table. So I can isolate traffic. This is great for service providers. Customer A, there's your routing table. Customer B, there's your routing table. Fantastic stuff. We're going to do this in SD-WAN. We're not going to call it a VRF. I know this is going to be weird because I'm going to call it a VPN, but then you're going to say, hang on, Patrick, a VPN is like an IPsec tunnel. Yes, we're also going to do that too. That's how we're going to connect our branch locations together. But all of the local LANs, so again, I'll come back to my example here. I've got my branch office in Northern Canada. Surely in that branch office, there's a couple of LANs, maybe, right? Like my clients, my guests, my staff. Those LANs, right? Those historically, you would have created maybe little VRFs. VLAN subnets, right, to isolate them. What I'm going to do is create what we're going to call VPNs. All that means is basically service-side, local LANs at the location for each one of those. I've got a really good kind of workflow of the whole thing to show you an example of that. What was the point of that? It was for this and for that, right? So I still want to do that, and we will do that. I talked a little bit about that when we talked about the zero-touch stuff. When I talked about management, you're going to want to do that from one single pane of glass. We're going to call that, we used to call it vManage, now we just call it SD-WAN Manager. A nice GUI where you can do all of that. This is very powerful as well. In my 30 minutes, I won't have time to do a deep dive on this, but what this allows SD-WAN to do is be aware of the application that your user is using. give you an example. Your user is using Office 365, and that branch location has an MPLS and an internet, just a straight internet connection. And you want them to use the MPLS all the time, unless it goes a little bit sideways, and then you want that internet connection to be used as a redundant path. What this will do is keep an eye on the performance, on the quality of the experience that the user is having connecting to Office 365, and it will react accordingly. I'll even simplify it. Let's say we don't even want MPLS. I've got a branch location, and I'm going to have two internet links, one to service provider 1, the other one to service provider 2. And service provider 1 is my preferred one. I'm going to monitor that. I'm not just monitoring the user's traffic. I'm actually talking to Office 365 to see what the health of that conversation is like. And I'll react accordingly. If it's not going well through that service provider, I'll fail over to the other one. Very, very powerful stuff. It's all about security. There's 2 levels of security for SD-WAN. Initially, when we build out the fabric, all of those devices, the control plane, the management plane, the data plane, they have to be able to talk to each other securely. Proper management conversations, control plane conversations, those are going to happen with DTLS tunnels. But when the data starts flowing at the data plane, we're going to use classic traditional IPsec tunnels for that. So again, if I have 1,000 branches in my data center, and I go hub and spoke, we're going to have 1,000 IPsec VPN tunnels all coming into that data center. Okay? I want all of that. That's clear. We've been using this now for quite a while. All flavors of cloud stuff. I need that to be supported, and it is. Super easy to integrate AWS, Microsoft Azure, GCP into the fabric and extend the network up. And I want all of this. I want to be able to do maybe actually 2 levels of security. I want maybe on-prem security to a certain level. So I'll go back to my example. Northern Canada, I've sent out that router, a real router, a Catalyst 8000. I've turned it on, it's joined the fabric. And then I go and have a look at the list, and like, I want to turn on the firewall. I want a little DNS security. And I want some inspection as well. That's all I'm going to do on the box. But I know that that box isn't like a massive router, so I don't want to turn on maybe too many security services. I turn around and I start leveraging stuff in the cloud. And I integrate my fabric with Umbrella SIG, and maybe I start using that for URL filtering, DNS as well, and whatever I need. So I can decide if I want to do some stuff on the box or in the cloud. You guys are still with me? So far, so good? Cool stuff. All right. This is the classic SD-WAN diagram, and I'm going to kind of zoom into each one as we go through. So, right, remember earlier I blew up the router and I pulled out the data plane and the control plane and the management plane. This is what it ends up looking like. So what are you looking at here? Like, we'll start at the bottom with the easy stuff and kind of work our way up. This is just the routers down here. These are your physical routers, your virtual routers, your branch locations. These are the IPsec tunnel between all of them, connecting back to the data center, connecting back to maybe a partner, right? So this is my classic data plane. I'm going to call these devices WAN edge routers. Some people we used to call them a V edge, and then some people call them a C edge. What was that all about? Well, when we bought the acquisition, we made the acquisition for Viptela, it was called a V edge, and then we started deploying SD-WAN on Catalyst, on iOS XE, so we started calling them a C edge, and now we got rid of all that, and I just call them WAN edge routers. It's just a generic terminology for when I have my router, I flick a switch, it's now doing SD-WAN, that's my WAN edge device. So that's down here. These are my transports, nothing too complicated here. Control plane, we're going to call that, used to be called a vSmart, we're going to call that the SD-WAN controller. It's the brains of the operation. Do I just want one brain? No, I might want a couple just in case something goes a bit sideways, right? I want some redundancy. This is where all the routing decisions are going to happen. And how do those routing decisions happen? Like, who makes that decision? You're making that decision, and you're doing that at the management plane, connecting to vManager. Now we call it SD-WAN manager. That's your single pane of glass. That's where you go click, click. I want to do this. I want to do that. I want to onboard a router, whatever I need. The one thing I didn't really talk about yet, because it's like an add-on to that whole blowing up the router, is the validator. It used to be called vBond. This guy is super, super, super important. We call them the devices at the orchestration plane. All that means is that this is the best way I can explain it is my gatekeeper. This is my bouncer. right? I've got my SD-WAN fabric up and running. I've just spun up a router in that branch office in Northern Canada. What did I say earlier? I'm going to connect my internet connection. It's going to get an IP from the service provider. DNS is going to resolve DNS to Cisco. Smart account. Smart account is going to say it belongs to me, and that router is going to call home. It's going to try to join my fabric. And who's it trying to connect to? This thing. And that's the bouncer. This is the device that's going to say, show me your credentials. Show me your certificate. Who are you? Show me your information so I can check my smart account, make sure that you're allowed actually to connect to it. And so I'm going to connect through this device, and it's going to be there to actually let the router in and join. And then once it's done its job, it steps out of the way. It's literally there just to allow that fabric connection initially. That's all. So like I said, I'm going to zoom in on each one of these. I don't really have much time to talk about this, but there is another platform where you can get loads and loads of analytics around how your SD-WAN network is performing. Okay, quickly double click on each one of these. So I just talked about this one. And pretty much, I think I'm repeating this. So maybe a first question someone is going to ask yourself is, where is this VBON validator thing? Where does it live? Is it like a real box? It's a virtual machine. It's in the cloud because your devices need to be able to reach it, right? I mean, you can hide it behind firewalls and do all kinds of stuff, but it needs to be available. If there's lots of NAT happening, for example, if I go back to that my branch office in Northern Canada, I've got that little router deployed, but maybe there's a firewall kind of in front of it, and there's some NAT happening there. So the VBON or the validator will help kind of sort that out and figure out how to get through that. At the end of the day, when that router wants to join your fabric, it needs to be told a few key pieces of information. What are the IP addresses of the controllers? What are the IP addresses of the managers, right? So that it can actually join the fabric and then get its configuration. The control plane, like I said, it's the brains of the operation. This is where all the routing decisions are going to happen. And SD-WAN, I don't mention it here, it's coming up in another slide. SD-WAN uses a particular routing protocol to do all it has to do. It's called Overlay Management Protocol. If you look at that protocol really, really closely, it looks a lot like, smells like BGP, like BGP in disguise. It's doing a lot of stuff around attributes. And so if you're familiar with BGP, you'll understand how OMP works. The reason I'm making that analogy is because it acts a lot like a route reflector. I'm going to give you an example. I've got 1,000 branch offices, 1,000. I go to one and I create an extra subnet there. But all my 999 other branches need to be able to reach that. There's an important service that they need to talk to. So they all need to know that that little subnet now exists. That router will advertise that information to the controller. The controller is going to say, okay, what do I need to do that? All right, I need to reflect. I need to advertise that subnet to all of these other ones, or maybe not all of them, but some of them anyways, right? So it's going to act like that classic BGP route reflector as well. Management plane is pretty straightforward. It's the GUI. That's where you're going to log in and create all of your policies, security policies, data forwarding policies. There's a couple of different flavors of these, control plane and data plane policies. That's where you're going to create all of your templates to configure. And this is where the power of SD-WAN, I think, is really, comes to play. Is, again, if I have 1,000 branch offices, they all get the same router. Maybe they should all get a good chunk of the same config as well, all across them. I do that in Manager. I create a basic default template so that when these routers join my fabric, they pull it, and they've got at least that basic one. I'm going to go even further than that. I'm going to say, okay, if it's pulled that template, I've got 1,000 branches. Okay, some of the config is the same, but there are some differences. Maybe some IPs, right, would be different. I can have variables, and the variables are linked to a CSV file. So now I've got 1,000 routers. I've got a CSV file. My template is pulling information from there so that each location gets its own IP information. Super powerful. And then this one is, like I said, it's just the routers. Here, they could be real physical routers. They could be virtual routers. They're going to build those IPsec tunnels I was talking about. I guess this is the kicker here as well, right? If this is my little branch location, where is it? There it is, right? Let's say this router is at my branch. Maybe I'm running the HRP, OSPF, BGP even, static routing. Maybe I've got a few of these and I'm doing PRRP. It supports all of that. So that's no problem. I mentioned this thing. That's the routing protocol. That's the routing protocol that's going to be used to have conversations between my controllers and then down to my WAN edge routers. That's where all of my routing decisions are going to happen. Do I want all of these locations talking to each other? Do I want that hub and spoke setup? Which prefixes do I advertise? Which ones do I hide? Right, maybe by global, by zone around the world. So I can do all of that through the controllers, through the routing protocol. Going quickly because I really want to get to a little work. We only have a few minutes left, so bear with me for a second. I'm going to go through this one quickly, and I'm going to get to the example of a fabric build-out. So this is just a little 4-step example of how an initial fabric kind of gets set up. So I've got all of my branch offices, my data centers, and they're connected to 2 transports, right? So this could be Internet 1, Internet 2, or MPLS and Internet, or MPLS and 5G, doesn't matter. So initially, I'm gonna turn on, right? The routers are gonna turn on, and as they turn on, they're gonna gather a little bit of information. They're gonna have a system IP to identify them, like a router ID in OSPF, for example. So hello, my name is, and I'm connected to a BGP transport, and we're gonna use the term color. So if I say color MPLS, I'm just talking about the transport itself. If I say color 5G, it's just that transport. And I'm going to have to figure out what kind of encapsulation I'm going to use. There's 2 options. It could be GRE or IPsec. We tend to use IPsec more than anything else. So the router, nothing, as you can see, I have nothing happening here at this point. The routers are just turning on. As soon as they do that, they're going to connect to the controller over DTLS and say, hi, my name is router 1.1.1.1. I'm connected to these 2 transports, and I'd like to build out IPsec tunnels. We're going to send all of that to the controller. Now, what did I say earlier? I mentioned that by default, it's going to want to build a full mesh topology by default. So the controller will reflect, if you like, back to all of the other locations, the existence of all the other routers, right? So all of these advertise themselves up here, and then this one said, hey, look at all these, right? A bunch of other routers. 2.2.2.2, 3.3.3.3. They're also connected to these 2 transports, and they also want to connect over IPsec. And then if you haven't done anything, they're going to build out a full mesh of IPsec tunnels. So you could turn that off. You can go hub and spoke if you need to as well, but by default, that's what's going to happen. Only have literally a minute. This is like my favorite part of the whole 30 minutes. I want to explain a little walkthrough of what I've just talked about. So here we go. You ready? 2 locations. I've got the WAN edge router over here with a system IP and a site ID, just to identify the site where it's located. It's connected to these 2 transports, and I have something similar on the other side. Nothing has been built out so far. I'm about to turn on these routers. So as soon as I turn them on, what's going to happen? We're going to build DTLS tunnels to the controller so that we can have a safe, secure conversation between each other. And what are we going to send in terms of information? Well, we're going to run OMP, and OMP is going to carry all of that stuff I just mentioned a few seconds ago. It's going to say, hi, my name is 10.255.255.11. I'm at site 10. I'm connected to these 2 transports, and I'd like to run IPsec VPNs. Let's go. We're going to send all of that to the controller. That's going to be an OMP update. Once that happens, the routers can then start establishing IPsec tunnels between each other, all the different locations. This is going to be full mesh again by default. And then what's going to happen within those tunnels, we're going to run our good old friend BFD. What that stands for, BFD, bi-directional forwarding. What's the point? What's the point of BFD? Sorry? Thank you, yeah. It's making sure that my link health is good. Yeah. So I want to make sure, and I keep checking the link here, the tunnel, to make sure that it's healthy and it's happy. Remember I talked about quality of experience. We can tie that into that as well, right? So is the link good? This is where things get interesting. I'm at this branch location. I turn on an interface. This is a subnet. I'm going to call that VPN1. This is where things get interesting. I'm going to do the same thing here. I know you're going to say, why are you using the same number? Well, because maybe I decided that I want these people to be able to talk to these people. And that will happen. This is like the same VRF. And then I can go a little further. I can open another one. Now, here we go. Can these guys talk to each other? Nope. Can VPN2 talk to VPN1? Nope. Can 1 talk to 1? Yes. And then can 2 talk to 2? Yes. I can do route leaking, but by default, I'll be isolating all these. So this is really good. Employees, guests, for example. These ones I can route out to the internet. These ones I'm allowing traffic to connect with us. 30 minutes. Policies that then start to flow, security policies, control and data plane policies. It was a little fast, 30 minutes. It's a lot to tell you. Like I said, I would really like to offer, I've got a slide, where's that slide? Yeah, so this is the book I'm talking about. Maybe last year, 6 months ago, it's not that long, we released, Cisco Press released a second edition of the SD-WAN book. So if you are planning on taking the exam soon, or you're actually in the middle of an SD-WAN deployment and you think you could use the book, stick around, come and see me on the side, and I'll give those. I've got 5 of them, so we'll see how that goes. Thanks for joining me, everyone. Appreciate you coming out. Cheers. Thanks.
All right, time to start. So welcome everyone to this this session. 30 minutes and you're going to learn all about the transformer. And hopefully this will be interesting for you because the transformer is the architecture, the secret sauce of how pretty much all LLMs and all generative AI works. So quick intro, my name is Rob Barton. So I'm a distinguished AI engineer and I work with our AI engineering software BU. So I'll talk, this is not going to be a product talk at all. So we're not talking about anything Cisco builds. Last slide, maybe I'll mention one little thing, but this is more the inner workings of how generative AI actually does what it does. So, just a quick history. Like we've been doing this now for a couple of years. I think 2022, November 30th was that pivotal moment in human history when ChatGPT was first unleashed on the world. And we all started using this. And of course, it's completely changed our world in a very, very short period. It's only like 3 years since GPT 3.5 was launched. But the history actually goes back much earlier. We can go back to the time of Alan Turing if you want. But really, the revolution started in late 2017. There was a very famous paper that was written at Google Brain called "Attention is All You Need," and they laid the sort of framework and the structure of what would become generative AI. And this was really trying to solve a problem that Google was facing around things like Google Translate, and they're trying to figure better ways to do this. And what we ended up, of course, creating were some pretty amazing things that have changed the world. And there's been just this onslaught of absolutely incredible innovation ever since. Even in 2025, you think of the things that have come this year, including starting January with DeepSeek, issuing a new model that could do things like mixture of experts and just different ways of handling things. And we'll see just continued innovation as we go through it. So when we look at this world of chatbots and talking to intelligent agents, we can think this is a very modern thing, but a lot of people are surprised that this whole world of chatbots started much earlier. In fact, if you go back to the 1960s, there was a program called ELIZA written by Joseph Weizenbaum at MIT. And it was kind of like a chatbot. You would talk to it and it would respond in a very human-like way. And people would actually even have an emotional reaction to some of the things it was saying. There's even a case of Weizenbaum's own secretary developing personal relationship connection with Eliza because of the way it would respond in such a human-like way. But it was not AI in the way that we think. It was not actually understanding any of the words. It was a logic-based system. It would look at the words. It would have a branching system and try to connect them and respond back with a question. But it gave this simulation of real life. Of course, what we're doing today is completely different because generative AI actually understands the meaning, the true meaning of words and the words in context in sentences and entire paragraphs. So if you look at the way we do things today, we're trying to basically do next word prediction. I think it's something we're very, very familiar with. You take a sequence of words and you try to predict what the next word would be in a sequence. That's what all of generative AI tries to do. If you look at this sequence of words from a famous movie, I'll make him an offer he can't. Can you guess what the next word would be? If you've seen The Godfather, you would know it's going to be refuse. What's actually happening in AI, it's not actually picking the word refuse as the answer. It's looking at every word of the entire vocabulary. And in the world of ChatGPT 3.5, that'd be like 50,000 words in its vocabulary. And every word has a probability associated with it. And simply the one with the highest probability is the one that it would select. So it's not saying this is the answer. It's looking at a probability distribution. Now, if we looked at all these other words, deny, reject, ignore, they're plausible, right? If you look at that's plausible, but it's not the right word, right? And you only come to the right word by looking at enough words in a sequence, which means you need context across that sequence to come up with the right word. Now, if you were to look at 50,000 words, most of them have a probability that's effectively 0, but the ones with the highest probability are the ones that typically the model would pick at the top of the distribution. Now, what's actually going on here? Well, in the world of generative AI and the transformer, we're looking at a collection of neural networks. Neural networks are made up of these little round things called neurons, artificial neurons, and these links between them, which are inspired by the human brain. Mathematically, these are what would be like a synapse, but these are connections in a neural network. So what's happening is you're passing a series of words, which are tokens, into this neural network, and it's trying to make a classification on its output. The classifier has equal number of classes to all the words of the vocabulary. So if this was GPT 3.5, it will have an output class of 50,000 possible choices. And the neural network's job is to assign the output class with the word, the highest probability, to be the one you would choose. So it's really a mathematical operation that's happening within this collection of neural networks. The modern transformer is not one neural network. It's an architecture of many, many, many neural networks that work together as a cohesive group. And I'll show you in a little more detail in a few minutes how that works. But ultimately, the output is a classification, and the job is to classify the right one. And then you'll see the word appear on the screen as it predicts. And it keeps predicting all the way till it gets a very special token called EOS, or end of sequence, which will be the next. It says I've said enough, no more tokens to write, and that's the next token that it predicts. So that's what's kind of going on inside of all of this neural network magic. Now, if you were to do this, of course, that neural network I showed you is based on math and numbers. Neural networks don't understand words as we know them. So how do you go from words to the output in math of creating that kind of output? Well, it's a multi-step process. The first thing you need to do is you need to break down your words into something called tokens. And we hear all the time, tokens. Time to first token, how many tokens am I consuming? I'm being charged by a certain number of tokens. So what is a token in the world of LLMs and generative AI? A token, you can think of it as the smallest atomic component of any word. So for example, in English, most words are compounds of other words from Greek and Latin and things like that. Those each subcomponents is a token. So think of the word unlikely. There's there's like, and there's ly. There's 3 different tokens that make up that. If I was to train the model on the entire word unlikely, you would have to see so many examples of that word over and over and over again to learn how to use that word and what it actually means. There's so many variations. There could be unlikelier, unlikeliest, unlikelier, plus a lot more contractions of these things. You don't want to do that. It's very hard. Your vocabulary would explode into a massive number of words. So what we do is we break down the language, the vocabulary of the language, into the smallest set of components that carry meaning. So un, like, and ly, they all carry a particular meaning. That's the vocabulary of the tokens. That's what makes the vocabulary of any language. So the first process you need to do is any word you tokenize, which means the words you're passing in, it chops it down to its smallest number of tokens. This is the OpenAI tokenizer. This word, if anyone can pronounce that, come and talk to me later because you'll win a prize, because I don't think it's not easy to pronounce. It's actually known to be the longest word in the English language. It's a medical term, some medical condition probably. There's 17 tokens, and you can see by the color breakdown, the different tokens that are in here. Every one of these carries a meaning. Now, if I was to train any model on that word, it would have to see many, probably hundreds of examples of that word to know how to use it, to know what it means. It's very unlikely you're ever going to see hundreds of examples of that word or any other long word. However, ChatGPT can still figure out its meaning because every token carries meaning. It's the tokens which it understands. That's why its vocabulary can be super efficient. You can get away with a vocabulary of 50,000 words, but actually understand hundreds of thousands of words because the combinations still make sense to the model. So the first thing it does is it breaks them into these tokens. In fact, I would argue that the algorithm they use, that generally data science uses to do this, is called byte pair encoding, BPE, is really one of those huge breakthroughs that allowed us to get LLMs to actually work. This whole concept of creating vocabulary from tokens. Once you've, of course, done that, those tokens have to be turned into some kind of number. LLMs don't understand words. They don't understand pictures. They don't understand sounds. They only understand one thing, which is math. They understand numbers. And there's calculations that are going on inside those numbers. So how do you turn all of those different tokens, thousands and thousands of them, into numbers? Well, this was a problem that Google was thinking about back in the 2012, 2013 era. And they were really trying to make Google Translate much more efficient. They were building neural networks to do this. And they said, we need to basically find a way to encode tokens into numbers. Well, how do you do that? The answer was you create a vector. So, and a vector has dimensions in it. And so they created an open source project called Word2Vec. So word to a vector. And they said, if we look at, lots and lots of examples of any word of our vocabulary, and we see enough examples, we'll start to encode the new numbers inside of this vector. They thought, well, how many dimensions do you need to describe a word? So they thought, well, maybe 300. 300 is a reasonable number that will capture a lot of different ways to look at the meaning, the richness, the depth, the subtleties, the subtext of words and how they're used. So they created this open source project, 300 dimensions for every vector of every word of the vocabulary. So you got 300 dimensions long for 50,000 words in your vocabulary. And they would just pass in lots of examples of words, and it would learn. It would, they're not programming this by hand. It's just learning by observing and trying to figure out these words. It was so successful that people quickly caught on to this idea, and they realized, this is capturing the depth of meaning of words, but it's captured mathematically. If you go to a word in the dictionary, you're reading the definition of a word. You're looking at how to pronounce the word, its use, sometimes the origin of that word. There's a lot of information in a dictionary. Think of that vector as capturing all that information. But what if you could capture even more information, like all the different, really, really nuanced and subtle ways that words are used? So in the modern era, like, ChatGPT, they don't use 300 dimensions. They use 12,288 dimensions for every single word. That allows them to capture an enormous amount of subtle detail, so subtle that it's even hard for humans to understand, but it would be things like cultural references to words. Things would be very hard to pick out, but if you see enough examples of it, you encode it into this very long vector. So this science is called word embedding, and it kind of has an interesting outcome. If you start to create vectors of numbers that represent words, and you can do this for your entire vocabulary. Do you remember in math, maybe back in high school or university, a vector kind of points at a certain place, right? It's got a length, and it's got a direction, and it's got, pointing somewhere. Well, now you've turned words into these vectors, and they point somewhere. And a fascinating thing started to happen. Words that had a similar meaning all pointed to the same area of space. So words that are synonyms, like big, large, huge, for example, and they would learn these vectors. They would kind of all point to the same area of space. And that was a fascinating discovery because it started to show that language actually has a mathematical structure that no one actually realized before, and they've been studying it ever since. In fact, if you were to take a look at, for example, take the vector for king, and then you mathematically subtract the value of man out of king, you're left with a vector that has some quality of royalty to it, and you add the vector of woman to it, it lands in the same place as the vector of queen. Like that's mind-blowing that words have a meaning which actually has a mathematical structure. And this might seem really obscure to you and weird, and why are we even talking about this? But it's these vector relationships that allows ChatGPT to do what it does. Everything is happening in this high dimensional vector space where vectors have a predictability to point to another one. Ultimately, what's happening is words are being shown across the screen. It's all happening in this high dimensional vector space, one word after the next, because those vectors carry so much meaning inside of them. Okay, so let's talk a little bit about the actual processing in the transformer. So you have all these words, right? Here's like Houston, we have a problem. That's the text I'm going to send into my LLM. Of course, we tokenize these, and then we create a vector. So this word Houston gets turned into a vector. They all have different vectors because they're translated differently. Now this is a little sample neural network here. This is like a little toy neural network, and the output classifier will pick the next token that it's going to write or predict for you to put on the screen. So what happens as you're putting all the tokens in, they don't go one at a time. It's not first Houston and then we and then have. They all go at the same time. Have you heard in LLMs of something called the context window? So show of hands if you've heard of a context window. Okay. Context window is how many tokens you can push into the model all at once. So for example, Claude Sonnet, famous model, has a context window of 200,000. What that means is it can read 200,000 tokens at the same time. It's not reading them one after the next, it's reading them all together. So everything you type on the screen, you put into your question for ChatGPT or anything, it's not looking word by word by word, it's looking at all the words in parallel. That's the size of the context window. So all these words come in, they're hitting a neuron on the input, it's reading them all together, all at the same time. This parallel processing was kind of a revolutionary change of thinking, and this was something they published in Attention is All You Need paper. This allowed us now to be very, very efficient in reading, to get context across massive, huge, long, you could like entire encyclopedia almost you can put in parallel, and it can read it. So that's one of the core concepts of generative AI is they do this in parallel. That concept was introduced in this paper in 2017. Attention is all you need. And if you look at the authors, they're all pretty much from Google Brain, except for Aidan Gomez. He was a professor from University of Toronto in Canada. He was a student of Geoffrey Hinton, who just won the Nobel Prize last year for a lot of his work on neural networks. They all worked on this idea. Parallel processing of tokens was one of their core ideas, which revolutionized the way we do neural networks. Now, the architecture that they came up with in this paper, they called it the transformer. And this is the architecture that they presented in the paper. It has an encoder and it has a decoder. And the idea is that you pass tokens into the encoder and it mathematically figures out not only just words anymore. Remember, so word embedding was converting words to numbers? They're not just in words, they're looking at the meaning of words across whole context. So, you have 10,000 words that all come in at the same time. It's understanding the relationship of those words. So a character in a story, it'll know everything that character did through the entire story with full contextual meaning. And it encodes this all mathematically. So this is an encoder. An encoder does not write anything. An encoder just reads, and it creates a rich, mathematical representation. What we're all using is on this side, is a decoder. So, this was the original architecture, but there's there's no uses, but there are some, but most of what we're using is a pure only decoder architecture. And you can see there's things like there's a multi-head attention, there's a feed-forward network. These are different types of neural networks that are working together to produce context to understand what's going on. Now, the attention mechanism is the secret sauce. This is what captured everyone's focus. The paper's called Attention is All You Need. It needs more than attention, but the attention mechanism is the absolute most important aspect of how modern Gen AI works. And the idea is that we're going to encode not just the meaning of a word, but we're going to encode the context of an entire sequence, no matter how long it is, up to the length of the context window. So what we're trying to do here is it reads in parallel, every word that comes in all at once, and it tries to understand how the meaning of those words relates to every other word in that sequence. So it literally knows the meaning of what you said. And I think you would have experienced this, right? When you go and use ChatGPT, doesn't it feel like it knows exactly what you're talking about? It actually understands even the subtlety of what you're saying, the subtext of what you're saying. It can really see, what you're really trying to get at. That's because of the attention mechanism. It's the attention algorithm which is able to do this. So I'm going to show you how the attention algorithm works. We're going to go through it in like hyper fast speed. So it's going to be, there's a lot here, but it's impressive. So let's take a look at two example, very short sentences. Who is Snow White and why is Snow White? Now, there's only one word difference between these two, but they carry a completely different meaning. Now, each of these words has an embedding. I showed you there's a vector of 12,000 dimensions for every one of them. So who and is and snow and white, they each have a 12,000 dimensional vector. That only defines the word itself. It doesn't define anything else other than just the word. Once I pass those vectors into the self-attention mechanism, it starts to look at how those words will relate to one another. For example, if you see the word who, doesn't that require a person's name? Like if you start a sentence with who, when you hear who is, you expect there to be a person's name to be in that sentence. And we've been trained through our own language skills to wait for that. Well, that's what the transformer has also been trained on. When it sees who, it knows to look for a proper name. In this case, Snow White. When it sees a why, it's trained to look for, why are, why is, whatever. It's looking for a verb followed by a noun and an adjective. It knows a sentence structure because it's just seen examples of the word why. So you put in who is Snow White. This is Claude. You can see a very nice explanation of Snow White and the 7 dwarfs. Now I go and change it to why, and it knows this is a scientific question, and it gives me a very accurate scientific output of why. One word change, but the context has completely changed between these 2 examples. What it has done, it's encoded these 4 words in its different vectors that encode the meaning and the context across that entire sequence, and they're completely different because of that one word. So that's intuitively what's happening. It's just encoding these numbers differently. So how does that all work? Okay, well, let's dive right into the attention algorithm inside the transformer, and you'll see how this works. And every LLM in the world is using a variant of this, whether it's GPT-5, Sonnet, BERT, doesn't matter. They're all using a variation of this exact same thing. Okay, so we start with who is Snow White. We start with these 4 words. What's the first thing we do? We tokenize them. What's the second thing we do? We turn them into word embeddings, right? So each word gets a 12,000 dimensional vector, okay? And you put these together, it becomes a matrix, right? You have 4 vectors that are combined together. Now, the first thing is it enters the attention mechanism, and it's split 3 ways. So one goes here, one goes here, one goes here. They're essentially 3 copies of the same thing. And then you notice there's 3 different little neural networks. There's a Q, there's a K, and there's a V. Each of these are trained through the training of the algorithm to do something different. What Q does, it's looking for what questions should I ask about a word. So for example, if the word is who, what question should I be asking? Where's a proper name? Like I'm looking for a name because I've got a who that I'm dealing with. I'm going to look around for something that is answering the who question. K is the key. So query and key. Key is the answer. So the key will say, I have an answer. Snow White is the answer to the question if I get asked about who. Now, every word gets a question and an answer. And it's going to combine these mathematically to give you that context. It will tell you what the meaning is. V is the value. Basically, think of it as the original copy. So we're going to do all kinds of context calculation here. By the end of it, you have context. This is the answer. So it's kind of like, if they just had the World Series baseball in the US. Imagine you got all the scores of the game, but you don't know which teams have those scores, right? This will be the scores. This is the name of the team, right? This gives you back the original, what you started with, so I can attach the meaning to the name. So that's what the V is all about. It attaches the original. Okay, so let's look at Q and K first of all. So Q asks the questions, right? So he takes that original embeddings and they get transformed. So they get enriched. They get changed a little bit with the questions that each word should answer. K answers them. And so you end up multiplying these 2 vectors, these 2 matrices or 2 vectors together using a special method in linear algebra called the dot product. If you remember, probably don't go run screaming, but I still have PTSD from linear algebra. But basically the dot product will just multiply these 2 and you end up with an answer. So it's a simple math problem. It's all it is. It's just a math problem. You take the query and the K, you multiply them with dot product, and the dot product has a very interesting property. 2 vectors that are very closely aligned at the result, that will give you an answer of high meaning. Like there's the who and Snow White, they will be very close because contextually, one answers the other. Ones that are either far apart or they're negative means they really have no relationship at all to each other. They get a low context score, a low attention score. So if you do this for each word, so for example, you're going to do white. In this case, the attention score, when I dot product them together, Snow and White have a super high score because they're related, because the one answers the other. For example, Y has to have an is. So these 2 have a very high dot product together. To make it simple, what we're doing is we're mathematically just combining 2 things together that tell us they have some kind of a connection. These 2 words are connected somehow. So when you do that, you end up with this great answer. Now you have to smooth things out because you might have big numbers, small numbers, negative numbers. You got to smooth them out. So we use a very well-known algorithm in AI called the softmax. Softmax, it's funny. It was why I did AI conference a while ago. This guy had this equation, softmax, on his T-shirt. I mean, that's kind of geeky, but that's how famous this equation is. It's probably the most famous equation in all of AI. It's called softmax. It normalizes them all out. Basically, this is the context. So these are context scores for who was Snow White. This is like the scores, right? The scores of the baseball game. What I'm missing now is the original sequence of words because I've done all these meaning calculation. So what I'm going to do is take the original V. This is my original values. Those are the original words. I'm going to staple them back together. So take the original words, which is my embeddings. I'm going to do a matrix multiplication of that context together. And what have I got as the output? I've now basically got the original words that have soaked up more meaning. Those embeddings now are transformed into something which is much more meaningful. It's not just the words alone anymore. It's now vectors that carry meaning with everything else around them. So they now have the original words plus the contextual meaning of the entire sequence. And that, in the essence, is what the attention mechanism does. For every single word you put in 200,000 words, it's doing this for all 200,000 across the entire context window, simply encoding mathematically the meaning into this space here. So this is what our decoder looks like. So this is the architecture that we're all using in ChatGPT and others. It all looks very, very similar to this. So we've got these multi-head attention, which I just showed you. This is that algorithm. That's where the real magic is happening. Now it's interesting. You see, there's another one here called the Feed Forward Network, the FFN. The FFN is kind of a classic neural network. It's been around for 20 years. There's nothing super fancy in FFNs. Why is there an FFN here? If attention is so amazing, it can do all these things. Why do we even need to have this this FFN? Because attention does everything. Well, it turns out it doesn't work without an FFN. The feed-forward network has a non-linear component inside these neurons. It's this non-linear component which gives extra level of meaning. I sort of think about it's like, you know, these detective shows they have on TV. Like the first half is the detective solving a crime and they're collecting evidence. That's like the attention mechanism. Then they go to the courtroom and they prosecute based on all the evidence that they've collected. That's like the FFN. These two are working together. So you need the linear of the attention, the non-linear of the FFN. Why does it work like this? Nobody knows. It just seems they've tried variations, one versus the other. It's one of those mysterious things of AI. It just seems to work, and it's really hard to know exactly why this is all happening that way. One last thing, when you go through ChatGPT, you're not going through a single decoder. You're actually going through 96 layers of decoder over and over and over and over and over again before, hey, finally, it's going to produce a token for you. Every time it goes through another decoder, guess what it's doing? It's getting deeper and deeper insights into that context, picking up richer meaning every time it goes through. So you're going through an enormous number of layers, every token that's actually getting produced on the screen. I wanted to just show this to you. You know, we talk about the parameters of models all the time. Oh, it's got like, you know, how many billion parameters, it's got a trillion parameters. You know, where on earth are those parameters actually? Like, it sounds kind of mysterious and hand waving. I've got all these parameters. I wanted to take just a sample model. And the reason I'm using GPT 3.5, even though it's older, it's because it's been published. The internal architecture is actually published for GPT 3.5. They haven't published 4 and 5. And they said they got 175 billion parameters in their model. So I wanted to say, well, like, really? So where are those 775 billion parameters? Do you notice here, query, key, and value? Remember we just saw that in the attention mechanism, those 3 different linear projection matrices. We have 96 heads and 96 layers of decoder. So you get around 14.5 billion of the parameters for each of those. But interesting, remember I said the FFN adds a non-linear component. So the FFN, I want to show you something absolutely fascinating. The FFN has almost 58 billion parameters on both the up and the down projection. So if you add up the total of 175, look how many of the parameters are actually in the FFN. You've got, you know, essentially, what is that, 118 billion of the parameters are in the feed-forward network, not in the attention mechanism. So I always like to joke where they say attention is all you need. Not true. There's actually more parameters in the feed-forward network than the attention mechanism. And again, why is that? I don't have an answer. I don't think anyone does. Like, that's an active area of research in data science. But that's essentially how you end up with this number. Modern models, are a little bit different. They're much bigger, trillions of parameters. But essentially, it's the same inherent architecture in all these different models. Cisco is also developing a model, in case you're curious. It's called the deep network model. So we are, building these models here to be network experts. So we're training this on how to solve networking problems, how to do reasoning through why is an application slow? Is the problem in the SD-WAN? Is it in the internet? Is it in DNS? And we've trained it on an extensive array of problem solving. Our model, by the way, we would consider this a fairly small model. It's about 27 billion parameters. But when we benchmark it, based on CCI exams, in case you're curious. It's you have to build a benchmark somewhere. So a 27 billion parameter model, we actually outperform, which is like GPT-5 is around a 5 trillion parameter model. So we're actually able to outperform it because it's fine-tuned on specifically in the networking domain. So that's it. We're out of time. So that went fast. That's the roller coaster ride of generative AI and how it works. Shameless plug. If you're actually wanting to learn more about this, I did write a book. It's not shipping yet, but this is the QR code, and it will be shipping in January. So we just finished the last draft, and you can get a copy of it. Go into way more detail, 400 pages of how all this stuff works in a lot more detail. So anyway, thank you for coming. Thank you.
Welcome, everyone. Can everyone hear me? Wonderful. Thank you for joining me this afternoon. This session is Imposters in the Network, Exploiting Identity for Access. I'm Sheila Kishan. I'm a solutions engineer with Cisco. I've been with Cisco for over 14 years. I started as a network engineer, designing and deploying large-scale networks, and then I transitioned to identity and access management focus. So I'm an identity solutions engineer now. So before I jump in, there is a WebEx space for questions, but also I'm available after the session if you want to have a quick chat about your use case or if you have any questions. So why are we here? Identity has been the foundation of security for a long time. In the past year, we realized that over 60% of breaches, cybersecurity breaches, used identity as a key component, right? Whether it's compromised credentials or phishing attacks, it always had identity as a key component. And especially around the network infrastructure area, we've noticed that there's been increasing attacks on identity infrastructure. Nearly half of all identity attacks were targeted at Active Directory servers. We also noticed that there's been increasing attacks on network devices, right? That's your routers and firewalls and switches as well. So it's not just applications that are getting compromised, it is also the network infrastructure. One of the key attacks that we realized was around South Typhoon. If you've heard about it, it's a state-sponsored attack against telco network infrastructure. So they were targeting large-scale telco providers, critical infrastructure, where they were compromising network devices. They were gaining access to network infrastructure and kind of gathering data, right? And then exfiltrating later on. And this is an analysis done by Talos. I have included the Talos blog as well if you're interested in learning more. So the way they did this was obviously with a compromised credential in the beginning, and then they accessed one of the network device what was open to public. Once they access the network device, from there, they then moved laterally, right, to other infrastructure devices within the network. So obviously using SSH connectivity to gain access to other network devices. And what they also did was kind of change network configurations, right? So they would create loopback interfaces from which they could source that SSH or telnet session to other network devices. And to cover their tracks, they would go and delete that or clean up that config once they were done gaining access to other devices, right? And that's how they moved from device to device, gathering information. They actually created network architecture diagrams based on, what they could find in the network configurations as well. And so they were specifically targeting TechAX and Radius protocol authentication. But through that, they were also gaining information about BGP passwords and RSVP passwords and things like that, right? And SNMP credentials. So that was something interesting that we found with this particular Salt Typhoon based attacks. And that's where we kind of realized it's not just, your applications that need protection. It's also your infrastructure, equipments that would need protection, right? Especially if you're in the telco infrastructure service provider area, or if you're running critical infrastructure as well, right? So the goal of this session is to kind of educate you on some of the security controls that are available that you can use with some of the Cisco platforms. Now, this is not a detailed session on everything this solution can possibly do, but I have focused specifically on network infrastructure and servers and so, right? So the first one we'll look at is how we can protect your network devices, anything that use TechAX, right? So how can you implement additional security controls? Now, typically when you protect your network devices, it would be via AAA, right? So you would configure AAA for all the logins. You might have a TechAX server where the user can authenticate and, authorize themselves before they log in. But if the user's primary credentials is compromised, then that's it, right? Like anyone can log in and gain access. It wouldn't be anything unusual because it will look like a normal user logging in. And especially if you think about running a network infrastructure, typically with applications, we can say, hey, if a user logs in at the middle of the night to do something, it's unusual. But I know that most of the network engineers, when they do change management, it is in the middle of the night, right? Like your change managements are never during the work days, during the weekends and late nights. So there's nothing unusual when a network admin logs in and does changes to the configuration, right? So this is where you can put in an additional authentication factor to your network devices. Now, many of you would have used hardware tokens, right? Like RSA tokens and things like that as well in your roles to protect your network devices. So think of it something like that, but a little bit more modern. So this is where we can use Cisco Duo and Cisco ICE platform to protect login to your network devices. Duo is our identity security platform. So it provides identity and access management, MFA, things like that. And obviously ICE is our identity service engine. It provides NAC and other solutions, but in this specific case, we are looking at using ICE as a TechAX server, right? So when a user logs into a router or a switch, a network device, obviously they do SSH. Your network device will use AAA TechAX to reach out to your ICE server, which will use as the TechHack server to authenticate the user. Now, TechHacks, or in this case, ICE, will then reach out to Active Directory where your user credentials are stored to do that primary authentication, right? So think of it as username and password verification, which is stored in Active Directory. Once the primary authentication is successful, so in this case, even if an attacker compromises your credentials, so that will be successful in that case, ICE will contact Duo to say my primary credentials are validated. Now it's time to initiate the secondary authentication, right? Secondary authentication is, when you normally log into an app, you get a push notification, or you can do a SMS code or whatever. That's exactly what would happen with Duo. Duo will send a secondary authentication notification to your user, and the user will have to authenticate themselves again. So how does that protect against attackers? In most cases, the attackers wouldn't have compromised the secondary authentication. It's very easy to compromise passwords, but it's very difficult to compromise your secondary authentication, right? So especially if you're using something like a mobile app to authenticate your users, they would have to approve that authentication to then go in and protect themselves. So once that is done, then the user will have access to the actual device. Obviously, you can apply any authorization policies with ICE as well, and then you can do any role-based control with ICE. So that's pretty much a simple setup. There are different ways to do it, but ICE and Duo now have native integration. So ICE natively integrates with Duo. So some of the requirements for doing this is, first of all, you need ICE version 3.3 for this native integration. You can do this even if you have older version of ICE, but that typically uses something called as authentication proxy, and I'll cover that in a little bit. So ICE, the version 3.3, that's what you need for the native integration. From a licensing perspective, this feature is available at the Duo's base tier license, so what we call Duo Essentials license. From an ICE perspective, you need ICE Advantage license, right? From a configuration, it's quite simple. You basically create two API integrations between ICE and Duo, and I'll show the configuration how that's done. So it's called Admin API and Authentication API. Admin API is usually used to sync the user between ICE and Duo. Essentially, if you have hundreds of users or even tens of users, the last thing you want to do is manually create the user in AD, then go to Duo and then create the same user. When they leave, you don't want to go back and delete in every single place. So because of the sync, when you create a user in AD, ICE automatically syncs that user to Duo. When you want to delete a user in AD, ICE will automatically delete that user in Duo, right? So that lifecycle management is done automatically. The authentication API is the actual authentication workflow that I showed you earlier. So that's where the auth API is used. Now, obviously, we talked about user doing primary authentication. So that's where the Active Directory comes in, and that's just something you would set up with ICE itself and the Active Directory. And for the MFA side of things, under external authentication sources, you would go and create a MFA connection between Duo and ICE. You can also select which Active Directory user groups you want to authenticate through ICE and Duo. So that's an option you can do when you do the configuration as well. So this is a simple demo of how that actually works, the steps that I explained. So this is the Duo admin portal. You would go under applications and just click on add applications. There you can just search by the name. So if you search Cisco ICE, it would give you the option of both admin and auth API. So you can see that there's an admin API and auth API. Just click on add application. What's important is that key. So that's what we will use to configure Duo as well. And then for admin API, for the user sync, you will select read and write. So obviously the ICE can delete or like add users. So that's what we're doing here. Save the configuration, right? So that simple in terms of admin sync. Next, what we need to do is set up the authentication API. Same steps, you would go there and add the auth API, in this case, or ICE auth API, select, add the application. You will get a similar page. You can enable this for all users or selected user groups. So these are the AD groups you would have synced to Duo, and you can select that. In this case, we will just enable it for all users. Again, there's some API keys. You would copy that and keep it, which you will then later on use it within ICE to do this configuration. You can see there's a whole number of policies there. Now you can use these policies because you can say, I want users to only log in from certain network locations or use certain authentication methods. So those are the restrictions, and you can configure these policies per user group or per application, or you can apply the policies for all globally, right? So that's what we're doing, and that's the Duo configuration, and you're done. There's no more configuration there. This is ICE. So within ICE, you would go to the administration settings and external identity sources. You see that we have already added AD there. Now we are only adding MFA. If you click on MFA, it will say, create the Duo connection, right? You can give it some name, something that's, makes sense to you. So just give it a name. Once you give it a name, the next step is to configure that connection between ICE and Duo. So that's where all the API stuff comes in. So you have the admin API keys. The API hostname will be unique to your Duo tenancy. So that will be common. And then you just enter the API keys for admin API as well as the authentication API, right? Once you've configured that API connectivity, you can test the connection. In terms of the network connectivity that is required, ICE will use port 443 to communicate to Duo Cloud. Obviously, Duo is hosted in the SaaS platform, so it's a cloud-based platform. But it is only outbound communication that we need, right? So outbound for port 443 to that particular API that we had, the API host name. So that's the only outbound connection that you need to allow. Once you have done that, you can create the identity sync. This is where, you kind of select which AD groups you would like to send to Duo, which AD groups you want those, which user groups you want to authenticate, right? So you can select that. Once you're done, you can verify the configuration, and that's pretty much it in terms of the configuration itself, right? So now when a user tries to log into a router or a switch, like I said, so the connectivity will go to ICE, which will do that authentication and then send the notification to the user. In a couple of slides later, I'll tell you from user experience what the user will have to do, but this is more from an administrator perspective. So that's for routers and switches, right? The next type of infrastructure devices is your servers, your Windows and Linux servers, right? We can also protect that with Duo. You don't need ICE for that. We have native integrations available for your Windows and Linux agents as well. The workflow is kind of similar in terms of how the servers will communicate. So when a user logs into the Windows or Linux server, once the server authenticates the user, that's the primary credential, so username, password. Once that is done, the server will initiate a connectivity to Duo, same port 443, outbound connectivity to that API, and Duo will do the same thing, right? Initiate a two-factor authentication to your user. Quite similar to what we did for ICE in terms of the traffic flow. It's except that you no longer need ICE as a proxy server to initiate that connection. You have a native host there, and that's it, right? So once that is done, the user will be successful. So to do that, similar to what we did with ICE, you would go under Duo. You look for the RDP application. So that's Microsoft RDP, and this type of integration protection works both for local login, also RDP login. I know this says RDP, but it can also be local console login. So you will just do add, and then you will have the same API keys, which you'll then configure within the Windows server. In terms of what it does and what it supports, it's for either local or domain joined server, so it can protect both. It is, like I said, for local console login as well as for remote desktop logins. You can also use for UAC. So when you say run as administrator type login, right? What it doesn't support, this integration doesn't support the PowerShell CLI type authentication. We do have another integration that is available. It's called Windows CLI MFA. So you will have to use that for CLI type authentication. In terms of the Windows systems it supports, it can do both clients as well as servers. So you can do all these servers as well, but clients is like if you want to roll out MFA for your Windows PC, right? It can do that. Some of you might be using Windows Hello for Business, things like that to log into your Windows machine. There's also Duo equivalent of Duo passwordless, which you can use to log in. So that's what this covers. In terms of your server configuration, it is a program that you can download from the Duo portal, and it's an installer that can run in your Windows machine. When you start the installer, it's the same. The API hostname will be unique to your account, so your tenancy. So just copy the API hostname. Now, there may be instances where not every server is directly connected to internet, right? Like that's not possible. It might go through a proxy. So if you do have a proxy within your environment, internet proxy, you can configure that proxy information as well. Same thing. When you add the application, you'll get the integration key and the S key or the secret key. Just copy that and put that out here. This is for UAC elevation. If at all you want that, run as administrator kind of settings. You can also see there's offline. So it is not just for online when the server can connect to Duo Cloud. We do also support offline as well, and I'll cover that. This is what it looks like from a user perspective, right? So when I do a RDP to a Windows machine, after my username password, it will bring up this kind of a dialog box which says, hey, authenticate yourself, and depending on what you have configured within the Duo portal, it can be the Duo mobile app where you get a push notification. It can be a phone call where the user will have to press a number, or it can even be a passcode, right? Like a SMS passcode or a token, hard token passcode that they can enter. What we have also done is we can also do something called as verified push. Now, some of you might be using number matching in Microsoft, where you see a number displayed in your PC and then you have to enter the number. It's the same thing. So in Duo, we call it verified push. So you can see that it displays a code here. The user will have to enter that code within their Duo mobile app before they can authenticate themselves. So that's in terms of the Windows online authentications. So what that means is the server needs to be able to talk to Duo, which is hosted in the internet, right? But there might be times where, the server drops internet connection. What do you do then? Right? Like you still need to be able to log in, but it might not be connecting to the internet. You don't want to get locked out. So there are two options that are available. You can do fail open, which means that if it is not connected to the internet, don't do MFA, just log in with primary credentials. Good. Security wise, probably not, because somebody can just stop your internet and gain access. The other option is called offline authentication. So within Duo, I know it's a bit tiny, but there's something called as offline authentication, which you can enable for Windows Server. We support Duo mobile passcode, and then if it is local login, we support like a USB key that you can plug in. You can say for which groups you can allow this offline login. Obviously, you would want it for those break glass accounts, not for every account. So you can select that. You can also define how long or how many times the offline login is valid, right? So maybe it can be valid for 10 times before the user has to connect to the internet. So that's configurable. So you can obviously change that at any point in time. And then when the user logs in, it will prompt them to enroll into the offline one. right? So same thing for Unix, that is SSH login as well. And in terms of SSH, like I said, we also do command line protection within Windows. The steps are quite similar. There's nothing different. So you can just follow the exact same steps. Finally, for Radius applications, right? So some of your firewalls might still be running Radius authentication. If they are, if you can migrate them to SAML, please do that. But if you can't, you're still stuck with Radius, then we do have a solution for that as well. It is by using something called as authentication proxy, right? Think of it like, if you're aware, Windows Microsoft NPS server, that's the Radius server. It's something similar, but with Duo. Similar thing, your Radius application will talk to this proxy server, which is like the proxy Radius server. Then with that proxy server can talk to primary, for primary credentials. For example, it can talk to Active Directory. But once that is done, the Duo authentication proxy, again, outbound 443 to Duo Cloud, and then you can configure whatever you need to do there, right? So it can be the mobile, passcode, SMS, etc. The Duo authentication proxy server itself it's again a program that you can run on a virtual machine. It can be a Windows virtual machine or a Linux-based virtual machine. We have programs available for both. If you do use Windows authentication proxy, you also get a sort of like a GUI to configure that, which is a bit more user-friendly than a Linux file. But if you are comfortable with Linux, then that's available as well. It's entirely up to you. What you kind of see here is, this is where we would configure all the information that the proxy would need to talk to either your the Radius application, to your Active Directory, to your Duo Cloud, right? So those are all the configuration. Once you configure this, you can click on validate. So which is like, it's running a validation check to see, hey, do you have everything configured correctly? Is there something missing? It also runs connectivity check. So it sees if it can connect to your Active Directory, for example, right? By default, it uses LDAP. You can configure it to use LDAP, secure LDAP as well. You can change the ports in which it communicates, based on what is in your network. But if you want, otherwise it will just use the default port. The same way, it will see if it can communicate with Duo Cloud on port 443. Again, it's the default port that we use. So it will run those connectivity checks. And the other one is that if you're using the authentication proxy server, if you're running it on a server which is domain joined, it can automatically connect to Windows, your domain controller, and log in using those domain joined accounts to, basically it needs to verify the users, right? But if it is not on a domain joined machines, then you would probably need a service account for this authentication proxy to reach out to Active Directory. It doesn't need write permissions. It only read permission to basically, check, hey, whether this user is there, and, whether we can validate that particular user, right? So in terms of configuration, there is various combos of configurations that you can use. This is just one example. The top is where we are configuring authentication proxy to talk to your Active Directory. So that's the Active Directory server on top, which is the host. Obviously, in this case, we are using a service account for auth proxy to talk to the Windows machine, the Active Directory. And then you can also select what Active Directory groups that you need to talk to, right? So you can do that configuration as well. The one you see in the bottom is where you're configuring authentication proxy to communicate with your Radius application, right? So let's say, for example, your firewall, which is using Radius application. So that's the, that's the Radius IP address, and this is the Radius secret between the firewall and your authentication proxy. And the I key, S key, API host, or everything that you would get from the Duo portal, right? Same thing. You would go there and say, hey, add this particular Radius application. We have generic Radius. If you have named Radius applications, that's available as well. You would repeat that configuration. So that's in terms of configuring the connectivity. From a user perspective, you can send email enrollment to your users. I know it's a little bit tiny, but it is available in our Duo portal if you want to take a look. So you can create custom emails here and say, hey, you're enrolled into Duo security. Follow these steps to self-enroll or add yourself to Duo, right? So the user will get an email, and this will be your company's logo with a link. Once they click on the link, they will be taken to this page where it will say, hey, follow these steps, right? So it's quite simple in terms of, enrolling themselves. So they just click on get started. It will give you the options. These options are dependent on what you have configured within Duo portal as an administrator. But let's say if they clicked on Duo Mobile, it will give them the link to download Duo Mobile app from Apple Store or Google Play. Then they can scan a QR code and then just add themselves, right? It's quite simple in terms of a user experience. And we also have guides to help your users on how to do this. So just to summarize, protect your network infrastructure devices. Whatever critical infrastructure you have, do protect them with two-factor authentication. If you have ICE, then use ICE plus Duo native integration for your network devices. For your Windows logon, use those native Windows integration. Same thing for your Linux devices, right? I didn't cover monitoring specifically, but there's a huge piece in itself. Do monitor your user login activity. If you have any kind of monitoring system that focuses on identity security, do enable that and monitor for these unusual activities, especially to your critical infrastructure. And I think with that, we have completed our session. If you do have questions or if you need to discuss more, feel free to reach out to me. I'll be more than happy to have this conversation with you. And thank you.